Hello dear students, welcome to our channel Maths with Panindra. In this video, we are going to discuss about indefinite integrals. All VSAQ'S whichever are very important for the public examination or board examination. It will help for TS and AP students, not only boards and CBSE boards also. It will help this video. Please like and share to your friends. Let us have a discussion. The first question here. Find integral cot square x dx. Integral cot square x, we didn't have any formula. So, by using trigonometric identities, cot square x in terms of cosecant, if you write, we have the formula in integration for cosecant. So, cot square x can be written as, what is the formula for, what is the identity of trigonometry? Third identity of trigonometry is cosecant square theta minus cot square theta is equal to 1. From that, cot square x you can make as a subject. So, cot square x can be written as cosecant square x minus 1 into dx. Now, split into two integrals. Integral cosecant square x dx minus integral 1 into dx. So, integral dx. Integral cosecant square x minus cot x minus integral dx x after completing of integration plus c. This is the way you have to do that integration. Now, we will move to the question number 2. Find integral x power 6 minus 1 divided by x square plus 1. By observing this given integral, the numerator degree is 6, denominator degree is 2. It is improper fraction. So, whenever improper fraction is there, first you have to convert into the proper fraction and then integrate. So, how to convert into the proper fraction? By actual division you have to do, dear students. See here, x power 6 minus 1 divided by x square plus 1. So, x power 6 minus 1 divided by x square plus 1 is going to write as, how many times is going to divide x power 6 with x square? X power 4 times. X power 4 into x square, x power 6. X power 4 into 1, x power 4. So, while subtracting sign change, these two will be cancelled. Minus x power 4 minus 1. So, again x power 4 minus x power 4. How many times? Minus x square times. Minus x square into minus x square minus x power 4. Minus x square into 1 minus 1. Here, minus x square into minus x square minus x power 4. Next, minus x square into 1 minus x square. Yeah, 1 minute, dear students. Here, x square minus 1 or plus 1, we'll check it. Yeah, the question is correct only, dear students. Here, minus x square into x square is minus x power 4. Minus x square into 1 is minus x square here. So, while subtracting sign change, plus, these two will be cancelled. Minus 1 plus x square. So, x square minus 1. So, x square minus 1, how many times is going to divide this value? So, x square only one time. Plus 1 into x square. 1 into minus plus 1 is plus 1. So, while subtracting sign change, this will be cancelled. Minus 1 is minus 2. This is the remainder. So, we can express x power 6 minus 1 by x square plus 1 can be written as, this is the quotient, x power 4 minus x square plus 1 plus a remainder by this were divided. So, how many, what is that remainder here? Minus 2 divided by x square plus 1. Now, this is improper fraction, we convert into the proper fraction. Now, in place of this, you have to take this value and then integrate. Therefore, here place is not sufficient. integral x power 6 minus 1 by x square plus 1 dx is equal to integral, in place of this you have to replace this value, x power 4 minus x square plus 1 minus 2 by x square plus 1 into dx, which is equal to, each and every term you have to integrate, integral x power 4 dx minus integral x square dx plus integral 1 into dx minus 2 into integral 1 by x square plus 1 into dx. Integral x power 4, integral x power n is x power n plus 1 by n plus 1. X power 4 plus 1 by 4 plus 1, that means x power 5 by 5 minus integral x square, x power 3 by 3 plus integral dx is x minus 2 into integral 1 by x square plus 1 tan inverse x plus c. This is the way you can do, dear students, this type of question. First you have to convert the given question into the proper fraction by this way. After that, each and every term we have to do that integration. Now we will move on to the another question number 3. Integral root of 1 plus sine 2x dx. Here 1 can be written as sine square x plus cos square x. Sine 2x can be written as 2 sine x cos x. So the given integral, first you have to make it like this way. Square root of 1 can be written as sine square x plus cos square x. Sine 2x can be written as 2 sine x cos x into dx. Now it is in the form of a square plus b square plus 2ab. A plus b whole square we can write now. So integral square root of sin x plus cos x whole square into dx. So here square root will be cancelled. Integral sin x plus cos x into dx. So each and every term integrate. Integral sin x dx plus integral cos x dx. Integral sin x minus cos x. Integral cos x sin x after integration plus c. This is the way we will do that. We'll move on to the next questions. The next questions. These type of questions very easy. Why the students are feeling difficulties? But the thing is, before starting the session of integration, please, dear students, you once again you revise the formulas of integration. Minimum formulas you need to practice. The reciprocal of formulas, that means reciprocal means the inverse process of differentiation is called integration. No? So minimum formulas of differentiation as well as integration you need to thorough. Then only the subject is easy. When lecturer explains these type of questions, you feel very easy. At the time of examination, whenever you are presenting the answers, that time you feel difficult. That is the reason you need to practice more the formulas first and then problems. So now come to the questions. Integral 1 plus 2 by x minus 3 by x square. First integration apply for each and every term, which is equal to integral 1 into dx, integral dx. Integral 2 by x into dx, 2 we can take outside, constant. Integral 1 by x into dx minus 3 we can take outside. So the rest of the term is 1 by x square dx, which is equal to integral dx is x plus 2 into integral 1 by x log mod x or simply log x minus 3 into integral 1 by x square minus 1 by x. Suppose if you do not remember the formula, integral 1 by x square is minus 1 by x. 1 by x square can be written as x power minus 2. After that you can apply integral x power n formula, x power n plus 1 by n plus 1. So that time n is equal to minus 2. So please remember, in case if you do not remember the formula, integral 1 by x square as minus 1 by x. So what we will do is, integral 1 by x square can be written as x power minus 2. So I apply exponent formula. But here I am writing directly, integral 1 by x square is minus 1 by x. After completing of integration plus c, and write it, final answer, x plus 2 log x or log mod x, minus into minus is plus, 3 into 1 by x is 3 by x plus c. We'll move to the next question, number 5. Integral x into dx plus integral 4 by 1 plus x square dx. 4 constant we can take outside. Integral 1 by 1 plus x square into dx. Integral x dx, x power 1 here. X power n derivative integration is what? X power n plus 1 by n plus 1. So, x power 1 plus 1 by 1 plus 1 plus 4 into integral 1 by 1 plus x square. We have the formula, integral 1 by 1 plus x square is tan inverse x. So 4 into tan inverse x plus c. We'll move to question number 6. Here also each and every term we can integrate. Integral e power x into dx minus integral 1 by x into dx. 2 constant you can take outside of the integral. Integral 1 by square root of x square minus 1 into dx. Integral e power x is e power x minus integral 1 by x log mod x plus 2 into integral 1 by root of x square minus 1. Integral 1 by root of x square minus 1 means cos h inverse x. Suppose the same formula plus is there here, sin h inverse x. 1 by root of x square minus 1 is there, cos h inverse x. Otherwise log mod x plus root over x square minus 1 also we can write it. E power x minus log mod x plus 2 into log mod x plus root over x square minus 1. Not compulsory to write this, students. Till here also we can stop there. Move to the question number 7. So integral 1 by 1 minus x square plus 1 by 1 plus x square dx. First split into 2 integrals and then apply formula directly. Integral 1 by 1 minus x square dx plus integral 1 by 1 plus x square dx, which is equal to integral 1 by 1 minus x square is tan h inverse x, hyperbolic inverse function, tan h inverse x plus integral 1 by 1 plus x square tan inverse x plus c after integration. We'll move to the question number 8. Here also first integration apply for the terms. Integral 1 by square root of 1 minus x square plus 2 into square root of 1 plus x square. Observe, dear students, 1 minus x square is there means integral 1 by 1 minus x square is sin inverse x. In place of minus plus is there, sin h inverse x. So first apply integration for the term, first term, integral 1 by square root of 1 minus x square dx plus 2 constant we can take outside, integral 1 by square root of 1 plus x square into dx, which is equal to integral 1 by root of 1 minus x square is sin inverse x plus 2 into integral 1 by root of 1 plus x square sin h inverse x plus c. Until here we can stop, but one more step, sin inverse x plus 2 into sin h inverse x is log mod x plus root over x square plus 1. We can write like this also. Not compulsory to write, till here also we can leave it. We'll move on to the next questions. next question. Integral, this we may expect in the public examination day, students. It's very important that these two questions especially, and 12 and 13 also. Integral e power log 1 plus tan square x dx. First, 1 plus tan square x we have to simplify. From identity of trigonometry, 1 plus tan square x is equal to secant square x. So, integral, first you have to write given integral, e power log of 1 plus tan square x is equal to secant square x into dx. After that we have formula e power log f of x is equal to f of x. So e power log f of x is what here? Secant square x. So integral secant square x dx, which is equal to integral secant square x tan x plus c. That's it. First 1 plus tan square x we wrote as secant square x. After that e power log f of x can be written as f of x. So f of x is secant square x. Integral secant square x is tan x. Now come to the question number 10. Integral sin square x by 1 plus cos 2x. Here you make a note. 1 plus cos 2x is equal to 2 cos square x. 1 plus cos 2x is equal to 2 cos square x. See, integral sin square x by 1 plus cos 2x is 2 cos square x into dx. So 2 we can take outside, 1 by 2, keep bracket, integral sin square x by cos square x, tan square x into dx. But we didn't have direct formula for tan square x. In terms of secant you can convert 1 by 2 integral tan square x, secant square x minus tan square x equal to 1, no? So from that tan square x make as a subject. Tan square x is equal to secant square x minus 1 into dx. Now each and every term integrate. Half into integral secant square x dx minus integral 1 into dx, which is equal to 1 by 2, keep bracket, integral secant square x tan x minus integral dx is x. After completing of integration, put that constant c. I hope you understand. Once again, 1 plus cos 2x can be written as 2 cos square x. So 2 constant we can take outside. Sin square x by cos square x is tan square x. Tan square x we didn't have formula integral tan square x, so converting into the secant. Secant square x minus 1 split into 2 integrals. So integral secant square x is tan x, integral dx is x. This is the way. Now move to the question number 11. Here also direct formulas we have. Integral 3 by root x minus 2 by x plus 1 by 3x square dx. So here 3 constant we can take outside. Integral 1 by root x, 2 root x. Integral 1 by root x is 2 root x. Make a note. Integral 1 by root x is equal to 2 root x. Suppose if you do not remember, 1 by root x means 1 by x power 1 by 2. X power 1 by 2 can take into the numerator. X power minus 1 by 2. Apply exponent formula integral. So instead of doing these things, if you remember simple formula, integral 1 by root x is 2 root x. So 3 into integral 1 by root x dx minus 2 constant you can take outside, 1 by x into dx, plus 1 by 3 constant you can take outside, 1 by x square into dx. So 3 into integral 1 by root x, 2 root x, minus 2 into integral 1 by x, log mod x. In the last question also we got it. Integral 1 by x square. In the last question also we got it. Integral 1 by x square is minus 1 by x. So 1 by 3 into minus 1 by x. After that plus c. So therefore 6 root x minus 2 log mod x minus 1 by 3x plus c. Now come to question number 12, 13, both are same type of question, which is very important. Both are integral cos hx dx plus integral 1 by root over x square plus 1 into dx, which is equal to integral cos hx sin hx hyperbolic trigonometry function sin hx plus integral 1 by root of x square plus 1, x square plus 1 is there, means sin h inverse x plus c. That's our answer. We'll move on to question number 13. Integral sin hx first split into two terms. Integral sin hx dx plus integral 1 by x square minus 1 whole power 3 1 by 2 into dx. Integral sin hx dx plus integral 1 by whole power 1 by 2 means square root of x square minus 1 into dx. Integral sin hx is cos hx plus integral 1 by root over x square minus 1 cos h inverse x. We'll move on to the next question set. The next question. Integral a power x minus b power x whole square by a power x b power x dx. So first, in the given integral numerator, you have to expand by applying the formula of a minus b whole square. After that, we can split and then integrate. Integral a minus b whole square expansion I am doing. A power x whole square plus b power x whole square minus 2 into a power x into b power x, numerator expansion completed, by denominator a power x into b power x dx, which is equal to integral a power x whole square divided by a power x into b power x dx plus integral b power x whole square by a power x into b power x dx minus integral 2a power x b power x divided by a power x b power x dx. So here one of the a power x will be cancelled, which is equal to integral a power x divided by b power x into dx plus integral one of the b power x will be cancelled, b power x divided by a power x into dx minus a power x b power x will be cancelled. So 2 is there, we can take outside constant, integral dx, which is equal to integral a power x by b power x can be written as a by b whole power x into dx plus integral b power x by a power x is b by a whole power x minus 2 into integral dx. It is in the form of integral a power x. So here I am writing the formula for integral a power x. Integral a power x dx is equal to a power x by log a plus c. In place of a by b is there, no? So it will becomes a by b whole power x divided by log of a by b to the base e. Even here also log a to the base e you can write it. Plus integral b by a whole power x is b by a whole power x divided by log of b by a to the base e minus 2 into integral dx is x plus c. That's all. This is the way you can do, dear students. I hope you understand. We'll move on to the question number 15. two methods I am going to give that. Whichever the method is easy for you, that you can follow. The first method is integral secant square can be written as 1 by cos square x into cosecant square x is 1 by sin square x into dx, which is equal to integral 1 into 1 is 1 by sin square x into cos square x dx. Numerator 1 can be written as sin square x plus cos square x. Integral sin square x plus cos square x divided by sin square x into cos square x into dx. Now split into two terms. Integral sin square x by sin square x into cos square x dx plus integral cos square x divided by sin square x into cos square x dx. Sin square x, cos square x, cos square x. 1 by cos square x dx plus integral 1 by sin square x dx. Integral 1 by cos square x is secant square x. Integral 1 by sin square x is cosecant square x. Dx. Integral secant square x d by dx of tan x is secant square x. Now similarly integral secant square x is tan x. Integral cosecant square x is minus cot x plus c. Now method 2. In method 2, integral secant square x into cosecant square x dx. Integral secant square x in terms of tan I am going to write. Integral secant square x can be written as secant square theta minus tan square theta equal to 1 now. So secant square x is equal to 1 plus tan square x. So tan square x plus 1 into cosecant square x dx. Actual multiplication. Integral tan square x into cosecant square x dx plus integral cosecant square x dx. Integral tan square x means sin square x by cos square x into 1 by cosecant square x is 1 by sin square x only, no? Plus integral cosecant square x, direct formula we have minus cot x. Integral 1 by cos square x minus cot x. Integral 1 by cos square x, secant square x, integral minus cot x. Integral secant square x, tan x minus cot x plus c. So observe, dear students, both the methods are same. Whichever method is easy for you, that you can follow. We'll move on to the next questions. The next question, integral 1 plus cos square x by 1 minus cos 2x. 1 minus cos 2a, formula we have 2 sin square a. So by using this formula, the given integral will becomes integral 1 plus cos square x by 2 sin square x. So we can split into terms. 1 by 2 constant you can take outside. 1 plus cos square x divided by sin square x. So we can split into two terms. 1 by 2 integral 1 by sin square x dx plus integrals cos square x by sin square x dx. 1 by 2 integral 1 by sin cosecant dx plus integral cos square by sin square cot square x dx. So which is equal to 1 by 2 integral cosecant square x is minus cot x, but integral cot square x formula not there. So cosecant square x minus 1 dx. So in the next step we will integrate 1 by 2 minus cot x integral cosecant square x dx minus cot x minus integral 1 into dx is x plus c. So we can write conclusion 1 by 2 minus 2 cot x minus cot x minus cot x minus x plus c. I hope you understand, dear students. We'll move on to the next one. Again the same formula 1 minus cos 2 sin square a. So how the questions are asking based on that same category formula, integral square root of 1 minus cos 2x, that can be written as 2 sin square x dx. 2 constant we can take outside, so root 2 will come, root square cancel, remaining sin x dx, which is equal to root 2 into integral sin x is minus cos x plus c, that is equal to minus root 2 cos x plus c. After that, the next question, integral 1 by cos hx plus sin hx dx. So to solve this problem, one method is multiplying and dividing by cos hx minus sin hx. Another one is, one can be written as in hyperbolic trigonometric identities cos h square x minus sin h square x equal to 1. That I am taking in this problem. Cos h square x minus sin h square x, hyperbolic trigonometry identity, by cos hx plus sin hx into dx, which is equal to a square minus b square, a plus b into a minus b, cos hx plus sin hx into cos hx minus sin hx divided by cos hx plus sin hx into dx. So cos hx plus sin hx, cos hx plus sin hx cancel. Integral cos hx minus sin hx into dx, which is equal to integral cos hx dx minus integral sin hx dx. Integral cos hx sin hx minus integral sin hx cos hx after completing of integration plus c. I hope you understand. We'll move to the last question in this. Integral 1 by 1 plus cos x. You remember, dear students, integral 1 by 1 plus cos x or 1 minus cos x or integral 1 by 1 minus sin x, 1 by 1 plus sin x. Like these problems are there. Multiplying and dividing by, suppose in the denominator 1 plus cos x is there, multiplying and dividing by 1 minus cos x. Suppose in the denominator 1 minus sin x is there, multiplying and dividing by 1 plus sin x. This is the way you can do, dear students. Here integral 1 by 1 plus cos x is there. So according to this problem, what we have to do? Multiplying and dividing by 1 minus cos x. So integral 1 minus cos x by denominator a plus b into a minus b, a square minus b square. So 1 minus cos square x. Shall I write directly? 1 minus cos square x is sin square x. Otherwise one write it 1 minus cos square x by applying the formula a plus b into a minus b. So integral 1 minus cos x by 1 minus cos square x is sin square x into dx. After that split into two integrals. 1 by sin square x. Directly I am writing cosecant square x dx minus integral cos x by sin x is cot x. 1 by sin x is, here observe carefully, dear students, sin x square is there now, sin square x. Sin x into sin x. Cos x by 1 of the sin x is cot x. 1 by sin x is cosecant x. Integral cosecant square x minus cot x minus integral cosecant x cot x is cosecant x plus c. We'll move on to the next question. Yeah, here observe dear students, integral d by dx of cosecant x is minus cosecant x cot x. No? So integral cosecant x cot x means minus cosecant x. Already minus is there, minus into minus is plus. Yeah, the next question, dear students. From these questions onwards, substitution method of integration we are going to follow. So here, for this question, two methods I am giving. One is substitution, and wherever possibilities are there, that I am explaining. To solve this problem, this is very important. Integral e power x by e power x plus 1 into dx. Put e power x plus 1 is equal to t in the denominator, that is that value. Differentiate with respect to x. E power x derivative is e power x. Constant derivative 0. T derivative with respect to x, dt by dx. So cross multiply e power x into dx is equal to dt. So in place of e power x dx you have to replace with dt. The given integral will becomes dt by t. E power x plus 1 is t. So it is in the form of integral 1 by x dx only. No? So 1 by t dt. Integral 1 by t means what? Log mod t. So that is equal to log mod t is what? E power x plus 1. This is one method. Another method, by using formula format, or integral e power x by e power x plus 1 into dx. Here f of x is equal to e power x plus 1. Differentiate with respect to x. F dash of x is equal to e power x. So it is in the form of integral f dash of x by f of x into dx. Can we write like this? This is f dash of x, this is f of x. Integral f dash of x by f of x means log mod f of x formula. So which is equal to log mod. What is f of x here? E power x plus 1 plus c. So both the answers are same. Either formula application or substitution. Wherever possibilities are there, you can do any method, dear students, according to your convenience. Come to here, integral x square by root 1 minus x. Whenever like this situation is there, under root of 1 minus x is there, no under root value we can take as t square. So here, put 1 minus x is equal to t square. So dx I want. So differentiate with respect to x. 1 derivative 0 minus x derivative is 1. T square derivative is 2t. Again t derivative with respect to x, dt by dx. Cross multiplication. Minus dx is equal to 2t dt. So dx is equal to minus 2t dt. So dx value we got it. From here I am going to convert x value. Here x square is there. So 1 minus the t square you can take here, x may take subject, 1 minus t square is equal to x. So therefore the given integral will becomes integral x square. So x value is 1 minus t square. X square means 1 minus t square whole square by root t square into dx value minus 2t dt. So integral 1 minus t square means 1 plus t power 4 minus 2t square by root t square means t into minus 2t dt. T get cancelled. So which is equal to integral 2 constant you can take outside. If you multiply with minus, it will becomes first 2t square will come minus t power 4 minus 1 into dt. Integral 2, already 2 is there, 2 into integral t square is t power 3. Directly I am writing one. 2 constant, 2 we can take outside. Integral t square is t power 3 by 3 minus integral t power 4 t power 5 by 5 minus integral 1 into dt t plus c. Whenever t is there, replace with 1 minus x is equal to t square now. So from that t is equal to whole power 1 by 2. 1 minus x is equal to t square. So 1 minus x whole power 1 by 2 is equal to t. So square root we can take. So wherever t is there, 1 minus x whole power 1 by 2. 2 times of 2 by 3. T cube means 1 minus x square whole power 1 by 2 whole power 3. So 3 by 2. Minus 1 by 5 into 1 minus x square whole power 5 by 2. Minus 1 minus x square whole power t. T means what? Whole power 1 by 2. Plus c. I hope you understand, dear students. Wherever t is there, this is the way. Sometimes they will ask this type of questions. We'll move on to the question number 22. Is very important. Integral sine inverse x whole square by root over 1 minus x square. So what we can take the assumption, most of the students they will ask the doubt. So which function we have to consider as t? Whatever the function involving in that we can take. That function is having the powers. See here, if you observe here, that under root whole power 1 by 2, no? So this is having the power. And in this question, sine inverse x whole square by root 1 minus x square. Whatever the function, if you are going to assume as a substitution, the derivative is also occurring in the same integral. Sine inverse x, if you take as t, whose derivative will be 1 by 1 minus x square. It is there in this. Suppose if you take here 2 plus x, 2x plus 1 equal to t in this case. So differentiate if you do, the derivative also will come there. So come to here, this is very important, question number 22. Put sine inverse x is equal to t. Differentiate with respect to x. Sine inverse x derivative is 1 by root over 1 minus x square is equal to t derivative with respect to x, dt by dx. So cross multiply, dx only you can take here. So dx by root of 1 minus x square is equal to dt. For this 1 mark. So the given integral will becomes integral. In place of sine inverse x replace with t square. Dx by root of 1 minus x square value dt only, no? It is in the form of integral x square, integral x power n plus 1 by n plus 1. So t power 2 plus 1 by 2 plus 1 plus c, which is equal to what is t? Sine inverse x whole power 3 divided by 3 plus c. Suppose if you don't want to do this method, even alternate method by using like this formula application is also there. F of x whole power n into f dash of x into dx also we can do that. F of x whole power n plus 1 by n plus 1 model, it will becomes. See the given problem, we can write alternate, just I am saying, whoever it is interested, you can do that. Sine inverse x whole square by 1 by root of 1 minus x square into dx, na? This is f of x whole power n means 2. This is f dash of x obviously. So integral f of x whole power n into dx, f dash of x into dx is equal to f of x whole power n plus 1 by n plus 1. So n is equal to what? 2 here. So we can write as sine inverse x whole power 2 plus 1 by 2 plus 1 by using this formula. If you are interested, you can do this formula also. We'll move to the next question, number 23. So put here 2x plus 1 is equal to t. Differentiate with respect to x. 2 into x derivative is 1 and constant derivative 0. T derivative with respect to x is dt by dx. So but I want only dx here. So 2 dx is equal to dt. From that dx is equal to dt by 2. So this is the value of dx. So integral 1 by 1 plus t square in place of dx, dt by 2. So 1 by 2 we can take out, integral 1 by 1 plus t square into dt. Integral 1 by 1 plus x square is tan inverse x. So which is equal to 1 by 2 tan inverse t plus c. What is t here? We assume that 1 by 2 tan inverse of tx plus 1 plus c. We move on to the next question step. The next question is, students, integral x power 5 by 1 plus x power 12 dx. So to solve this type of problems, remember very easily, x power 5 is there, no? you have to increase one power, that is x power 6. X power 12 in terms of x power 6 we can write it. Integral x power 5 by 1 plus x power 12 can be written as x power 6 whole square into dx. Now x power 6 is equal to t. Put x power 6 is equal to t. Differentiate with respect to x. Divide x of x power n into x power n minus 1. So 6 into x power 6 minus 1 is equal to dt by dx. So cross multiply 6x power 5 dx is equal to dt. But I want only x power 5 dx. 6 we can take here. X power 5 dx is equal to dt by 6. This information if you put it here, 1 by 6 into integral x power 5 dx is dt by 6. No? 1 by 6 you can take outside, dt by 1 plus t square. Integral 1 by 1 plus t square is tan inverse t. So which is equal to 1 by 6 tan inverse of t plus c. What is t we assumed here? X power 6. 1 by 6 tan inverse of x power 6 plus c. We'll move to the next question. I already said that what we can assume that is t here. Cos is having the power. So cos x whole cube we can write into dx, sin x dx. Cos x whole power 3 into sin x dx. So put cos x is equal to t. Differentiate with respect to x minus sin x dx is equal to dt. But I want only sin x dx. Sin x dx is equal to minus dt. So integral t cube into minus dt, which is equal to minus integral t cube dt minus integral t power 3 is t power 4 by 4 plus c. What is t? Cos x minus cos x whole power 4 by 4 plus c. We'll move to the next question. This is very important. Both are all are important. Coming 3. Integral 1 minus 1 by x square into e power x plus 1 by x. Here what we can assume as t? See, if we take the power of e here, x plus 1 by x derivative is 1. 1 by x derivative is minus 1 by x square. It is there now. So that is the reason. Put x plus 1 by x is equal to t. Differentiate with respect to x. X derivative is 1. 1 by x derivative is minus 1 by x square is equal to dt by dx. So cross multiply dx we can take here. 1 minus 1 by x square into dx is equal to dt. So in place of this, replace with dt. Integral e power, this value is t into dt. Integral e power t dt is e power t plus c. That is equal to e power, what is t here? X plus 1 by x plus c. I hope you understand it, friends. We'll move to the next question. Integral 1 by root of sin inverse x into root of 1 minus x square dx. This type of question we already discussed when sin inverse x whole square is there in the numerator. Similar procedure here also we are following. Put sin inverse x is equal to t. Differentiate with respect to x. Sin inverse x derivative is what? Root of 1 by root of 1 minus x square is equal to t derivative with respect to x, dt by dx. So dx I am taking here. Dx by root of 1 minus x square is equal to dt. So, sorry. In place of dx by root of 1 minus x square dt, root dx by 1 by, this value is root t. In place of dx by root 1 minus x square is dt. Integral 1 by root x, 2 root x, that is equal to 2 root t plus c, that is equal to 2 root sin inverse x plus c. We move to the next question number 28. Integral sin power 4x by cos power 6x into dx, which is equal to integral sin power 4x by cos power 6x also in terms of 4 and 6 we can write it. So cos power 4x into 1 by cos square x into dx. So anyway it will become cos power 4x. Sin power 4 by cos power 4 is tan power 4 x. 1 by cos square is secant square x dx. After that, put tan x is equal to t. Why? Because this is having the power. So this is also having the power. But observe the derivative of which function is. So derivative of tan x is secant square x only. No, that is the reason tan x is equal to t. Differentiate with respect to x. So secant square x is equal to dt by dx, cross multiplication. Secant square x dx is equal to dt. So it will become integral t power 4 into dt. T power 4 into dt. Integral t power 4 is t power 5 by 5 plus c, which is equal to tan power 5x by 5 plus c. I hope you understand now. We'll move on to the next questions. Next question. Integral sin square x dx. Integral, we didn't have direct formula for integration of sin square x. So sin square x can be written as 1 minus cos 2x by 2. So 1 by 2 we can take outside. Integral 1 into dx minus integral cos 2x into dx. 1 by 2. Integral dx is x minus integral cos 2x. We have formula. Integral cos ax dx is equal to sin ax by a. So integral cos 2x is sin 2x divided by 2 plus c. We will move to the question number 30. Integral 1 by root of 4 minus 9x square. Two methods are there. One is formula application, one is substitution method. All are explaining in terms of substitution only, no? So what I am doing is, this given integral can be written as 1 by root of 4 can be written as 2 square minus 9x square can be written as 3x whole square. So put 3x is equal to t here. Put 3x is equal to t. Differentiate with respect to x. So 3 into x derivative is 1, t derivative is dt by dx. That implies 3 dx is equal to dt, but I want only dx. Dx is equal to dt by 3. So this given integral will becomes integral dx value is dt by 3 by root of 2 square minus t square. Integral 1 by root of a square minus x square. A square minus x square. Sin inverse x. 1 by 3 into sin inverse x by a. That means t by 2 plus c. What is t we assumed here? 3x. 1 by 3 sin inverse of 3x by 2 plus c. We will move to the question number 31. So here also integral 1 by 1 plus 4x square can be written as 2x whole square into dx. Put 2x is equal to t. Differentiate with respect to x. 2 into x derivative is 1, t derivative is dt by dx. So 2 dx is equal to dt. Dx is equal to dt by 2. So therefore, integral 1 by, in place of dx 1 by 2 dt, 1 plus t square. 1 by 2. Integral 1 by 1 plus t square is tan inverse of t. So 1 by 2 tan inverse of, what is t here? T is equal to 2x. We'll move to the next question number 32. Integral 1 by root of 4 minus x square. Integral 1 by square root of 4 can be written as 2 square minus x square. This is the direct formula we have. That also I am mentioning here. Integral 1 by root of a square minus x square into dx. Integral 1 by root of a square minus x square is sin inverse x by a. So which is equal to sin inverse of x by 2 plus c. According to this question, we'll move to the I'm going to end the session. Number of questions are there. This is video 1 in indefinite integration. Video 2 tomorrow I'm going to give it. And by Wednesday I'm going to finish all circles also 2 marks questions I'm going to make it for your convenience. Thank you dear students for watching. Hi dear students, welcome to our channel. This is the continued video VSAQ'S of indefinite integration. Integral square root of 4x square plus 9 into dx equal to. Here 4x square can be written as integral square root of 2x whole square plus 9 can be written as 3 square into dx. Here only I am writing, put 2x is equal to t, differentiate with respect to x. So 2 into x derivative is 1, dt by dx cross multiply, and dx is equal to, just dx I am taking here, dt by 2 I am taking here. So this formula will becomes integral, in place of dx dt by 2. So 1 by 2 square root of t square plus 3 square. It is in the form of integral root of x square plus a square. Do you remember the formula? Integral root of, here I am writing, integral square root of x square plus a square dx is equal to x by 2 root over x square plus a square by 2 into sine h inverse x by a. So based on that, 1 by 2 keep bracket x by 2, x means what here, t by 2 square root of x square plus a square, t square plus 3 square plus a square by 2, 3 square by 2 sine h inverse x by a, that means t by 3 plus c. So 1 by 2, t value is what, 2x by 2 square root of t square 4x square plus 3 square 9 plus 9 by, sorry, a square by 2 now here. So 9 by 2 sine h inverse of 2x by 3 plus c. If you want to multiply with multiply, otherwise leave it like this. Here also 2 get cancel. Now come to the question number 34. This is equal to integral square root of 16 can be written as 4 square minus 25x square can be written as 5x whole square into dx. Same procedure, 5x is equal to t here. Put 5x is equal to t, differentiate with respect to x. So 5 into x derivative is 1, t derivative with respect to x is dt by dx. So dx and 5 I am interchanging. So dx is equal to dt by 5. So which is equal to 1 by 5 integral square root of 4 square minus t square into dt. Integral a square minus x square formula. Integral square root of a square minus x square dx is equal to x by 2 square root of a square minus x square plus a square by 2 sine inverse of x by a. So here 1 by 5 x by 2. So x by 2 means t by 2 square root of 4 square minus t square plus a square by 2. A square means what? 4 square by 2 sine inverse of x by a. X means what? T. T by a. A value is what? 4 plus c. Now wherever t is there, replace with 5x, which is equal to, here I am concluding, 1 by 5, t is equal to 5x by 2 square root of 4 square, 16 minus 25x square plus 4 square means 16 by 2 is 8 sine inverse of 5x by 4. You need to multiply by 1 by 5 also, otherwise leave it. Now come to the question number 35. Here also, so first make it integral square root of 9x square can be written as 3x whole square minus 25 can be written as 5 square into dx. So 3x is equal to t here. Put 3x is equal to t. Differentiate with respect to x. 3 into 1 is equal to dt by dx. So dx we can take here dt by 3. So which can be written as 1 by 3 into integral square root of t square minus 5 square into dt. Here we are going to apply the formula integral root of x square minus a square into dx. So x by 2 root over x square minus a square by 2 into cos h inverse x by a. Formula should be thoroughly, students, otherwise it is a problem. Compulsory x square minus a square means cos h inverse, and here middle will get minus. So 1 by 3 root of x by 2. X by 2 means t by 2 here. Root over t square minus 5 square minus 5 square by 2 cos h inverse of x by a. That means t by 5 plus c. So wherever t is there, replace with 1 by 3 into 3x by 2 square root of 9x square minus 25 by 2 cos h inverse of 3x by 5 plus c. After that, if multiply with 1 by 3, otherwise leave it like this, not a problem. We will move on to the next questions. The next question. Integral 1 minus tan x by 1 plus tan x dx. So just a quick revision. First I will explain. Integral 1 minus tan x can be written as sin x by cos x by 1 plus sin x by cos x into dx. Integral, take LCM, cos x minus sin x whole divided by cos x whole divided by cos x plus sin x whole divided by cos x into dx. For the denominator, cos x will be cancelled. Integral cos x minus sin x by cos x plus sin x into dx. After that, put cos x plus sin x is equal to t. Differentiate with respect to x. d by dx of cos x is minus sin x plus d by dx of cos x is sin x. Sin x is cos x is equal to t derivative with respect to x is dt by dx. Cross multiplying. So cos x minus sin x into dx is equal to dt. So in place of numerator dt I am going to replace integral dt by t. Integral 1 by t means what? Log mod t plus c. What is t we assumed here? So log mod cos x plus sin x plus c. We will move on to the next question. This is very important. We may expect in the public exam, dear students. These are all substitution method problems in this video. Integral e power tan inverse x by 1 plus x square dx. So whatever the function is involving in another function, that we can take as assumption. Put tan inverse x is equal to t in this case. So differentiate with respect to x. Tan inverse x derivative is 1 by 1 plus x square. T derivative with respect to x is dt by dx. So dx only we can take here. Dx by 1 plus x square is equal to dt. So 1 by 1 plus x square dx value is dt. So the given integral will becomes e power t dt. Integral e power t is e power t plus c. What is t? E power tan inverse x. Here also same, tan inverse x is equal to t. Put tan inverse x is equal to t. Differentiate with respect to x. Same procedure. 1 by 1 plus x square dx is equal to dt. Directly I am writing here. dt by dx, dx I am taking. So 1 by, here dx I forgot. 1 by 1 plus x square dx value is dt. This problem will becomes integral sin t dt. Integral sin t is minus cos t plus c. What is t here? Minus cos of tan inverse x plus c. Come to the 39 question. Here, integral log of 1 plus x by 1 plus x. Put log of 1 plus x is equal to t. Differentiate with respect to x. 1 by 1 plus x is equal to dt by dx. So cross multiply dx by 1 plus x is equal to dt. So therefore, integral t into dt. Integral t dt means what? T square by 2 plus c. T square means log of 1 plus x whole square by 2 plus c. I hope you understand, student. We'll move on to the next questions. The next question. Integral secant square x by 1 plus tan x whole cube into dx. So here, put 1 plus tan x is equal to, put 1 plus tan x is equal to t. Differentiate with respect to x. Constant 1 derivative 0, tan x derivative is secant square x. T derivative with respect to x is dt by dx. So cross multiply secant square x dx is equal to dt. This information is very important, dear students, which is equal to integral secant square x dx value is what? dt by t cube. So integral 1 by t cube, we didn't have any formula. 1 by t power 3 is t power minus 3 dt. So integral x power n formula, x power n plus 1 by n plus 1. T power minus 3 plus 1 by minus 3 plus 1 plus c. So minus 2 t power minus 2 by minus 2 plus c, that is equal to minus 1 by 2t square plus c. What is t? 1 plus tan x. Substitute here. Minus 1 by 2 into 1 plus tan x whole square plus c. Integral x cube into sine of x power 4 dx is very important and easy. Put x power 4 is equal to t. Differentiate with respect to x. 4 into x power 3 dx is equal to dt. So x cube into dx only I want. 4 we can take here. X cube dx is equal to dt by 4, which is equal to 1 by 4 into, in place of x cube dx dt by 4, 1 by 4 I have taken out, sin t dt. 1 by 4 integral sin t minus cos t, which is equal to minus 1 by 4 cos of t value x power 4. Now come to, this is also substitution method. 1 plus cos sin x is equal to t here. Put 1 plus sin x is equal to t. Generally I have to write assumption like here, but based on the convenience I am doing here. Differentiate with respect to x. So constant derivative 0, sin x derivative is cos x is equal to dt by dx. So cross multiply cos x dx is equal to dt only. So in place of cos x dx dt by 1 plus sin x is t square. Integral 1 by x square is minus 1 by x. So minus 1 by t plus c. So that is equal to minus 1 by t value, 1 plus sin x plus c. Come to the question number 43. Integral e power log x In the last classes we discussed that e power log f of x is equal to f of x. So by using that e power log x is x by x dx. So that is equal to integral dx. Integral dx is x plus c. That's the answer. Simple one. Now come to here. Integral x squared by square root of 1 minus x power 6 can be written as x power 3 whole square into dx. Now put x power 3 is equal to t. So differentiate with respect to x. 3x square dx is equal to dt. So 3 we can, x square dx only want, x square plus dx is equal to dt by 3. So 1 by 3 integral dt by root over 1 minus t square. Integral 1 by root of 1 minus x square is sine inverse x. So 1 by 3 sine inverse of t plus c, which is equal to 1 by 3 sine inverse of t value is x cube. We'll move on to the next set of questions. The next question, question number 45. Integral 2x cube by 1 plus x power 8 into dx. So first what we have to do is integral 2x cube divided by 2 constant you can take outside, 1 plus x power 8 can be written as x power 3 is there now, you have to increase 1 power, x power 4. So x power 8 in terms of x power 4 you can write it x power 4 whole square. I hope you understand, dear students. After that x power 4 is equal to t. Here put x power 4 is equal to t, differentiate with respect to x. So for x power 4 derivative is 4 into x power 4 minus 1, 3 into dx is equal to dt. Generally dt by dx we are taking here, but I want only x cube dx now. So x cube dx is equal to dt by 4. So in place of x cube dx you have to replace with dt by 4. Here already 2 is there. Integral dt by 4 means dt by 4 by 1 plus t square. 2 1s are 2 2s are. So 1 by 2 integral 1 by 1 plus x square tan inverse x. So integral 1 by 1 plus t square is tan inverse t plus c. What is t here? X power 4. So 1 by 2 tan inverse of x power 4 plus c. So come to here, same procedure you have to follow. This can be written as integral x power 8 divided by the 1 power you have to increase for x power 8, so x power 9. Denominator x power 18 can be written as x power 9 whole square. 1 plus x power 9 whole square into dx. So x power 9 is equal to t. Put x power 9 is equal to t, differentiate with respect to x. 9 into x power 8 is equal to dt by dx. So dx we can take here and 9 we can take here. So x power 8 into dx is equal to dt by 9. So it will become, in place of x power 8 dx, replace with dt by 9. So 1 by 9 integral dt by 1 plus t square. Integral 1 by 1 plus x square is tan inverse x. So 1 by 9 tan inverse of t plus c. What is t here? X power 9. So 1 by 9 tan inverse of x power 9. Now come to the question of 47. It's very important. Number of times they asked in the public exam. Integral e power x into 1 plus x by cos square of x e power x. So x e power x you can take as t. Put x e power x is equal to t. Differentiate with respect to x. uv formula. U into, u is x here, v is e power x. X into d by dx of e power x is e power x plus v into e power x into d by dx of x is 1 is equal to t derivative with respect to x is dt by dx. Cross multiply and e power x take common, e power x into x plus 1 into dx is equal to dt. So in place of numerator e power x into x plus 1 dx replace with dt. by cos square t. 1 by cos square x, secant square x. So integral secant square t dt. Integral secant square x is tan x. So tan t plus c. That is equal to tan of t value is what? X e power x. Now question number 48. Simple question. Integral e power x into sine of e power x dx. So here put e power x is equal to t. Differentiate with respect to x. So e power x is equal to dt by dx, cross multiplying e power x into dx is equal to dt. So in place of e power x dx, replace with dt. So integral sin t dt. Integral sin x minus cos x. So minus cos t plus c. That is equal to minus cos of e power x plus c. Come to the question number 49. Sin of log x by x. Whatever the function is involving, that we can assume as t. So put log x is equal to t here. Differentiate with respect to x. 1 by x dx is equal to 1 by x is equal to dt by dx. That implies that 1 by x into dx also we can take here. Dx is equal to dt. So in place of 1 by x dx, replace with dt. Integral sin t dt. We know that integral sin t is minus cos t. Minus cos t plus c. In place of t, log x. So minus cos of log x. The next question. Integral 1 by x log x log x. So here two possibilities are there to do that, but here I am giving only substitution method, not formula application. Put log x is equal to t. Differentiate with respect to x. Log x derivative is 1 by x equal to t derivative with respect to dt by dx. No? The dx also I am taking here, which is equal to dt. I hope you understand. So this integral will becomes integral 1 by x dx value is dt. So 1 by t dt. Integral 1 by t means what? Log mod t plus c. That is equal to log mod, in place of t, log x. Come to here. Here also same. 1 plus log x we are assuming that as t. Differentiate with respect to x. Constant derivative 0, log x derivative is 1 by x dx is equal to dt. So 1 by x dx value is dt. The given integral will become t power n into dt. Integral x power n plus 1 by n plus 1. So integral t power n is t power n plus 1 by n plus 1 plus c, that is equal to 1 plus log x whole power n plus 1 divided by n plus 1 plus c. This is also important mark. All are important. Previously they asked in the public exam. Number of possibilities are there in indefinite integration. So here put log x is equal to t. Differentiate with respect to x. 1 by x dx is equal to dt. So integral cos t dt. 1 by x dx value is dt. Integral cos t dt. Integral cos t is sin t plus c, that is equal to sine of t value is what? Log x plus c. So here root x is equal to t in this case. Put root x is equal to t. Differentiate with respect to x. Root x derivative is 1 by 2 root x. Dx is equal to dt. But I want only 1 by root x into dx. 2 we can take here. 1 by root x into dx is equal to 2 dt. So that is equal to integral cos t, in place of dx 2 dt. So 2 dt. So 2 into integral cos t sin t plus c, that is equal to 2 into sin root x. So root x is equal to t. Derivative of root x is 1 by 2 root x. dt by dx. So dx we are taking here. 1 by root x dx value is 2 dt. 2 we are taking here. So in place of 1 by root x dx is equal to 2 dt. 2 dt. Remaining is cos t. Integral cos t is sin t. So 2 into sin t plus c. In place of t, 2 root x substitute. 2 into sin root x. Now come to here. These two are special problems. Directly by using formula format I am going to do that, dear students. Here f of x is equal to x square plus x plus 1. So the derivative f dash of x is equal to x square derivative 2x, x derivative is 1. So it is looking like integral f dash of x by f of x only now into dx. It is in the formula format. Integral f dash of x by f of x dx is log mod f of x plus c. What is f of x? That is equal to log mod x square plus x plus 1 plus c. That's all answer. So here also you have to mention and it. Here differentiate respect to x. Even here also, here f of x is equal to x square plus 3x minus 4. Differentiate with respect to x. F dash of x is equal to x square derivative is 2x plus 3x derivative is 3. So this will become integral f dash of x by root f of x dx. Integral f dash of x by root f of x dx is 2 root f of x. 2 root f of x plus c. So 2 root f of x means what? X square plus 3x minus 4 plus c. We'll move on to the next questions. Next question is very important one. Integral 1 by x log x into log of log x. So this we can assume as t. Obviously the rest of the term will become dt. So here put log of log x. Log of log x is equal to t. Differentiate with respect to x. 1 by log of log x derivative is 1 by x. Sorry, 1 by log x. Log x. Log x means in place of x, log x is there now. So log x derivative is 1 by x. So log of log x derivative is 1 by log x. Again log x derivative is 1 by x equal to dt by dx. So dx I am taking here dt. So 1 by x log x dx, this value is equal to dt. So integral 1 by, in place of this t and dt, the rest of the term. Integral 1 by t is log mod t plus c, that is equal to log mod, in place of log t, log of log x. So now integral cot hx. Integral cot hx can be written as cos hx by sin hx dx. Here f of x is equal to sin hx. Differentiate with respect to x. F dash of x is equal to sin hx derivative is cos hx. So integral f dash of x by f of x into dx. Integral f dash of x by f of x means log mod f of x. Log f of x, that is equal to log f of x means what? Sin hx. This type of question also very important, dear students. How to solve these type of problems? The under root value you can assume as t square. So put x plus 2 is equal to t square. From that t is equal to root of x plus 2. Differentiate with respect to x. d by dx of x is 1 equal to t square derivative is 2t into t derivative is dt by dx. So cross multiply, dx is equal to 2t dt. So dx value we got it. Next x plus 3 I want. We know that x plus 2 is equal to t square. So x plus 3 I want, no? So x plus 2 plus 1 is equal to t square plus 1. We are adding 1 on both sides. So x plus 3 is equal to t square plus 1. Integral 1 by, in place of x plus 3, t square plus 1, square root of t square into dx value. Dx value is what? 2t dt. Integral 2t by t square plus 1 into root square cancel t into dt. Dt get cancelled. 2 into integral 1 by 1 plus t square dt. 2 into integral 1 by 1 plus x square is tan inverse of t. So that is equal to 2 into tan inverse of t value is what here? Root x plus 2. Now we will move to the question number 59. So only 2 steps answer, 2 marks. Root 1 plus cos 2x. 1 plus cos 2a is 2 cos square a. So root over 2 cos square x dx. Root 2 we can take outside. Integral cos x dx. What is integral cos x? Sin x. So root 2 into cos x sin x plus c. Now question number 60. Integral cos x plus sin x divided by root of 1 can be written as cos square x plus sin square x plus sin 2x can be written as 2 sin x cos x into dx. A square plus b square plus 2ab. So denominator will becomes cos x plus sin x whole divided by root over cos x plus sin x whole square into dx. Root square cancel. So therefore integral cos x plus sin x divided by cos x plus sin x into dx. Integral dx. Integral dx is x plus c. We'll move to the next set of questions. Yeah, next question. Question number 61. Integral e power x into cot e power x. So put e power x is equal to t. Differentiate with respect to x. E power x equal to dt by dx. Dx we are taking here. So in place of e power x dx dt, integral cot t dt. Integral cot x log mod sin x. So log mod sin t dt. Sorry, sin t plus c. What is t we assumed here? Log mod sin e power x. So come to here. So cosecant square x into root cot x. First you have to write like this. Cosecant integral cosecant square x cot x whole power 1 by 2. Root can be written as whole power 1 by 2. Put cot x is equal to t. The derivative of cot x is minus cosecant square x. So put cot x is equal to t. Differentiate with respect to x. d by x of cot x minus cosecant square x is equal to t derivative with respect to x dt by dx. Cross multiply minus cosecant square x dx is equal to dt. But I want only cosecant square x dx. So multiplying by minus cosecant square x dx is equal to minus dt. So this given integral will becomes integral cosecant square x dx equal to minus dt. So cot power 1 by 2. So t power 1 by 2 minus dt. So minus integral root t dt. Integral root x 2 by 3 t power x 3 by 2 plus c. What is t here? Cot x. So minus 2 by 3 into cot x whole power 3 by 2 plus c. We'll move to the next question. Integral secant x into log of secant x plus tan x. Log of secant x plus tan x we can assume as t. Put log of secant x plus tan x is equal to t. Differentiate with respect to x. Log x derivative is 1 by secant x plus tan x into again secant x derivative is secant x tan x plus tan x derivative is secant square x is equal to t derivative with respect to x is dt by dx. Take common secant x from there. secant x into tan x plus secant x by secant x plus tan x is equal to dt by dx. So these two will be cancelled. So the dx also we can take here. Secant x into dx is equal to dt. So in place of secant x dx, replace with dt. Integral log of secant x plus tan x is t into dt. So integral t dt, integral x dx, x square by 2. So t square by 2 plus c, that is equal to log of secant x plus tan x whole square by 2. Now we'll move to the next question. Integral cos cube x into dx. So how to do integral cos cube x? Direct formula is not there with us. But we know that cos 3x formula. Cos 3x is equal to 4 cos cube x minus 3 cos x. This is the formula we have. From that cos cube x make as a subject. Minus 3 cos x we can take here. Cos 3x plus 3 cos x is equal to 4 cos cube x. So 4 also we can take here. 1 by 4 into cos 3x plus 3 by 4 into cos x is equal to cos cube x. So in place of cos cube x, we have to replace with this and then integrate. Therefore, integral cos cube x dx is equal to integral 1 by 4 cos 3x plus 3 by 4 into cos x dx. So 1 by 4 we can take outside, integral cos 3x dx plus 3 by 4 we can take outside, integral cos x dx. Integral cos x sin x by a. So 1 by 4 sin 3x divided by 3 plus 3 by 4 integral cos x is sin x plus c, that is equal to sin 3x divided by 12 plus 3 by 4 sin x plus c. I hope you understand, students. We'll move on to the next set of formulas. The next set of problems which are helpful for especially AP students this year only, 2022 only. Integral e power x into f of x plus f dash of x into dx equal to e power x into f of x plus c. So by seeing the question, this type of question, you recognize this problem belongs to this formula. Integral e power x into f of x plus f dash of x into dx equal to e power x into f of x plus c. So first you have to recognize what is f of x, what is f dash of x in the given problem. So observe the question number 65. Integral e power x into sin x plus cos x into dx. If you are taking as sin x as here, f of x is equal to sin x, whose derivative is there immediately. Differentiate with respect to x, f dash of x is equal to cos x only, no, sin x derivative. So this is equal to integral e power x into f of x plus f dash of x into dx. This is equal to e power x into f of x plus c. What is f of x here? That we can replace. That's all answer. E power x into sin x plus c. Come to here. Here, f of x is what? Tan inverse x or 1 by 1 plus x square. F of x is tan inverse x, whose derivative, differentiate with respect to x, f dash of x is equal to 1 by 1 plus x square. So this formula will becomes, this given question will becomes e power x into f of x plus f dash of x into dx, which is equal to e power x into f of x plus c. What is f of x? Tan inverse x. So e power x into tan inverse x plus c. We'll move to the question number 67. But by observing it is not there in this form, first we have to making into that form. Integral e power x into split into two terms, 1 by x plus x get cancel log x into dx. Now among these two functions here, f of x is equal to 1 by x, log x. Differentiate with respect to x, f dash of x is equal to 1 by x, d by x of log x is 1 by x. So this formula will becomes integral e power x into log x value is f of x, f dash of x plus f of x into dx, which is equal to e power x into f of x plus c. What is f of x here? Log x. That you can replace. E power x into log x plus c. Come to here, the last question in this session. Integral e power x into secant x plus secant x tan x. Among secant x and secant x tan x, which function is f of x? Which function is f dash of x? Here, if we take f of x as secant x, differentiate with respect to x, f dash of x is equal to d by dx of secant x is secant x tan x. So this given integral will becomes integral e power x into f of x plus f dash of x into dx, which is equal to integral, this value is equal to e power x into f of x plus c. So e power x into f of x value is secant x. Yeah. Till this the VSAQ'S of second video of indefinite integration is over. It's more than enough. From this 100% you will get VSAQ'S. It will cover in AP and TS. I am expecting most of the questions I covered here. Still any doubts are there, write to my comment box. I will help you in my free time. Thank you all. Signing off. Maths with Panitra. Jai Hind. Hi, hello dear students, welcome to our channel Maths with Panitra. In this video, I am going to discuss about very short answer type questions from definite integrals. First 10 to 15 questions which are belongs to TS 2022 VSAQ'S. And not only first 10 to 15 questions but also other questions, it will help for the AP students VSAQ'S. Why? Because some little difference is there in the syllabus. That is the reason particularly I am mentioning. Some students in the previous videos, some students are asking, sir, you have to mention, sir, the questions which are belongs to AP or TS. First 10 to 15 questions which are belongs to 100% TS 2022 IP examinations. The other questions which are coming from, you remember TS students, only 7B exercise questions from definite integrations which are belongs to TS. Other than 7B questions which are AP also, you can proceed. Let us have a discussion. The first question, find integral 2 to 3 2x by 1 plus x square dx. For this question, we have two methods. One is substitution method, another one is formula application. See, substitution method means 1 plus x square is equal to t, you have to assume that, and get the 2x dx value in terms of dt. Whenever you are taking assumption, limits will change, upper limit and lower limit. Instead of that, what I am going to do is, our formula format I am taking here. In this solution step, here f of x is equal to 1 plus x square. Differentiate with respect to x. F of x derivative is f dash of x. Constant derivative 0. Plus x square derivative is 2x. So f dash of x is equal to 2x. So wherever 2x is there, you have to replace with f dash of x. Wherever 1 plus x square is there, f of x. So the given integral will becomes integral 2 to 3 2x by 1 plus x square dx is equal to integral 2 to 3 f dash of x divided by f of x into dx. We know that formula in indefinite integration, integral f dash of x by f of x into dx is equal to log mod f of x plus c we have to write, but it is definite integration, no need to put constant. By using this formula here, it will becomes log mod f of x. Applying the limits 2 to 3. What is f of x? Again you have to mention here. Log mod 1 plus x square. Applying the limits 2 to 3. First, in place of x upper limit, log 1 plus 3 square minus log mod in place of x lower limit 1 plus 2 square, which is equal to log mod 1 plus 9 minus log mod 1 plus 4, which is equal to log 10 minus log 5, log a minus log b, log a by b, log 10 by 5. So 10 by 5 is 2. So log 2 is the required answer. I hope you understand, dear students. We will move on to the next question number 2. So this is also number of times they asked in the public examination by using trigonometry. See here, integral 0 to pi square root of 2 plus 2 cos theta. Integral 0 to pi square root of 2 take common 1 plus cos theta into d theta. We know the formula for 1 plus cos theta. 1 plus cos theta is 2 cos square theta by 2. So integral 0 to pi square root of 2 into 2 cos square theta by 2 into d theta. 2 into 2 is 4. 4 we can take outside of the root. It will become as 2. So 2 times of integral 0 to pi square root of cos square theta by 2. That means cos theta by 2 whole square. Now square and root will be cancelled. 2 times of integral 0 to pi cos theta by 2. That means 1 by 2 into theta, d theta. It is in the form of integral cos ax dx. What is integral cos ax? Sin ax by a. So by using this formula, here a value is 1 by 2. Integral cos 1 by 2 theta. So sin 1 by 2 theta by 1 by 2. 2 into sin 1 by 2 theta by 1 by 2. Applying the limits 0 to pi. So denominator of denominator numerator, 2 times of 2 into sin of, in place of theta upper limit 1 by 2 into pi minus sin of 1 by 2 into 0, sin 0 0. So it leads to 2 into 2 times of sin 1 into pi by 2, sin pi by 2 is 1 minus sin 0 0, 2 2s are 4. Therefore the required answer for the given integral is 4. We will move on to the next question. Like next question number 3. Integral 0 to pi by 4 secant power 4 theta d theta. First what we have to do, dear students, integral 0 to pi by 4 secant power 4 theta can be written as secant square theta into secant square theta. You have to write it, and one of the secant square theta in terms of tan you have to write it. Here I am giving the formula identity. Secant square theta minus tan square theta equal to 1. So from this secant square theta make as a subject. Secant square theta is equal to 1 plus tan square theta. So here in this bracket, integral 0 to pi by 4 In place of first secant square theta, replace with 1 plus tan square theta into secant square theta d theta, which is equal to 1 into secant square theta, making into sum of two integrals, integral 0 to pi by 4, 1 into secant square theta, that means secant square theta d theta, plus integral 0 to pi by 4 tan square theta into secant square theta d theta. Integral secant square theta, direct formula we have. Integral secant square theta is tan theta. So applying the limits 0 to pi by 4. But what about here? Here integral 0 to pi by 4 tan theta whole square, tan square theta means tan theta whole square into secant square theta d theta. Here I am going to apply this formula. Observe carefully, dear students. One of the important formulae. Integral f of x whole power n into f dash of x dx is equal to f power n plus 1 of x by n plus 1. So f of theta is tan theta here, whose derivative is there, secant square theta. This is f of theta. This is f dash of theta. So it is in the form of f of x whole power n into f dash of x into dx. So first here, first term, in place of theta upper limit tan pi by 4 minus tan 0. So first term integral is over, plus come to here f of theta whole power n is equal to what here 2. F dash of theta is secant square theta, tan theta derivative is secant square theta. So it is in this form of integral f of x whole power n into f dash of x into dx. F of x whole power n plus 1. F of x means what here? F of theta. So tan theta whole power n plus 1, 2 plus 1 by 2 plus 1. For this, applying the limits 0 to pi by 4. Now you understand, I think. So tan pi by 4 is 1 minus tan 0 is 0, plus in place of theta upper limit pi by 4, tan pi by 4 is 1, 1 power 2 plus 1, 1 power anything is 1 only, by 2 plus 1 is 3, minus 0, in place of theta upper lower limit substitute 0, tan 0 is 0. So which is equal to 1 plus 1 by 3, which is equal to 4 by 3. We move on to the question number 4. Integral 0 to 1 by root of 3 minus 2x into dx. Even this question also substitution method we can do. If you take the substitution, limits will change based on the substitution. Instead of that, I am going to do in another way. The root value is there, no under root value, that I am taking as f of x. Here, f of x is equal to 3 minus 2x is equal to f of x I am taking. Differentiate with respect to x. 3 derivative 0, minus 2x derivative is minus 2, f of x derivative is f dash of x. Here in the numerator, I want to write in the form of integral f dash of x by root of f of x into dx is equal to 2 root f of x plus c. 2 root f of x. This formula I am going to apply. So in what way we will write f dash of x is not there in the numerator. This given integral I am going to write integral 0 to 1. F dash of x value is minus 2. It is not there in the numerator. What I am doing is minus 1 by 2. Here minus 2. Multiplying and dividing by minus 2. Divided by root of 3 minus 2x into dx. I hope you understand now. Multiplying and dividing by minus 2 to get into the formula format. Now this is in this form. Integral f dash of x by root f of x into dx. Integral f dash of x by root f of x dx is what? 2 root f of x. So minus 1 by 2 into 2 root f of x. F of x means what? 3 minus 2x. After that, applying the limit 0 to 1. So constant you can take outside and cancel it. Minus 1 by 2 into 2. For the rest of the terms, you can apply the limits 0 to 1. 2 to get cancelled. Minus. In place of x upper limit, root of 3 minus 2 minus root of 3 minus 0. So which is equal to minus 3 minus 2 is 1, root 1 minus root 3, which is equal to minus root 1 is 1 minus root 3. Multiplying by minus, it will become root 3 minus 1. So minus 1 minus of minus root 3 plus root 3, root 3 minus 1. Therefore, the given integral value is root 3 minus 1. We will move on to the next question. The next question, question number 5. Integral 1 to 5 dx by root over 2x minus 1. So to solve this type of problem, even last question number 4 also, this type of question we discussed. In the given integral, denominator here root 2x plus 1 is there. This you have to assume that f of x. First you write given integral 1 to 5 dx by root over 2x minus 1. I am taking here 2x minus 1. Put f of x is equal to 2x minus 1. Take it as f of x. Differentiate with respect to x. So f dash of x is equal to 2x derivative is 2, constant derivative 0. No need to write. So 2 is not there in the numerator. I want to write in the formula format, which is equal to multiplying and dividing by 2, integral 1 to 5, 2 divided by root of 2x minus 1 into dx. Same integral I wrote, multiplying and dividing by 2. Now this will be converting into the form of 1 by 2, integral 1 to 5, f dash of x divided by root f of x into dx. In the previous question also we discussed this formula. Integral f dash of x by root f of x means what? 2 root f of x. 1 by 2, 2 root f of x, applying the limits 1 to 5. So for constant, no need to consider inside, we can write it outside. 2 to get cancelled. What is f of x here? Root f of x is 2x minus 1. 1 to 5. In place of x, substitute 5. 2 into 5, 10 minus 1 minus x is equal to 1, substitute 2 minus 1. So root 9 minus root 1. So which is equal to 3 minus 1, which is equal to 2. I hope you are able to see here. Yes, you are able to see till here. So the answer is 2 for this question. We will move on to the question number 6. Here also same procedure we have to follow. In this question, put f of x is equal to x square plus 16. Differentiate with respect to x. F of x derivative is f dash of x. D by dx of x square is 2x and 16 derivative cos derivative is 0. So now 2x is not there in the numerator in the given integral. So I want to get here 2x. Multiplying and dividing by 2. The given integral as 1 by 2 integral 0 to 3 2x by root over x square plus 16 into dx. So here I am going to apply this formula integral. Once again I am writing f dash of x by root f of x into dx. 2 root f of x. So 1 by 2 f dash of x by root f of x means 2 root f of x. 2 root f of x means what? X square plus 16. Applying the limits 0 to 3. 2 to get cancelled. X square, x is equal to 3, substitute. Root over 9 plus 16 minus root over 0 plus 16, which is equal to root 25 minus root 16, which is equal to 5 minus 4. This is the way you can do this, students, for this. I hope you understand here this formula we applied. Now we will move on to the question number 7. Integral 0 to 1 x into e power minus x square dx. In this question, substitution I am going to do. Observe carefully. Put x square is equal to t. X into e power minus x square, whatever the power is there, whatever the function is involving in other function. E power minus x square is their exponential function. So in that power is x square, that I am taking as t. Differentiate with respect to x. X square derivative is 2x is equal to t derivative with respect to x is dt by dx. But I want only x dx here. So cross multiply first. 2x dx is equal to dt. The 2 we can take here. X dx is equal to dt by 2. So x dx value we got it. Whenever in the definite integration, whenever you are taking assumption, you have to change the limits, upper limit and lower limit. How to change? Observe carefully. Here upper limit is what? X is equal to 1. So x is equal to 1. X is equal to 1, substitute in this. So 1 square is equal to t, therefore 1 is equal to t. So in terms of t, it is going to convert the given integral. Similarly, lower limit, when x is equal to 0, 0 square is equal to t, 0 is equal to t. So lower limit will become t is equal to 0, upper limit is t is equal to 1. In this case, it is not changed, but we need to change it. Integral 0 to 1 x into e power minus x square dx is equal to integral, it will be converted. X dx value is dt by 2, so 1 by 2 into dt e power minus t. X square value is t, no? Integral e power ax, formula again. Integral e power minus ax dx is equal to e power minus ax by minus a. So here minus is what? Minus 1. So 1 by 2 minus e power minus 2. E power minus t, minus we can take out. Applying the limits, sorry I did not write limits here, 0 to 1. So minus 1 by 2 e power minus 1 minus e power minus 0. E power minus 0 or e power 0 is 1. Minus 1 by 2, e power minus 1 is 1 by e minus 1. So if you multiply by minus 1 by 2 into 1 minus 1 by e. So that is the way you have to give the answers. More 2 to 3 problems we will discuss. After that, modulus problem, compulsory one question will come. Modulus problem is conceptually important. I hope you understand, dear students. We will move on to the next one. The next question, dear students, is very important. These two models we may expect in the public exam. Integral 0 to 2 mod 1 minus x dx. See, mod x equal to plus x when x is greater than 0. Mod x equal to minus x when x is less than 0. But 0 to 2 is there, sir. Why you are writing x is less than 0, x is greater than 0? Here only, observe carefully, 0 to 2, in between 0 to 2, 1 is there, no? So 0 to 1, 0 to 1, 1 to 2. So this case is 0 to 1 means x is less than 1, 1 to 2 is x is greater than 1. So first the given integral you can split into two integrals. Integral 0 to 1 mod 1 minus x dx plus integral 0 to 1 mod 1 minus x dx. Sorry, here 1 to 2 mod. 0 to 1 integral mod 1 minus x dx, integral 1 to 2 mod 1 minus x into dx. Based on this interval, the function value will change. How it will change? Here I will explain. Carefully observe. Mod 1 minus x is equal to 1 minus x if 1 minus x is greater than 0. 1 minus x is greater than 0 means what? 1 is greater than x. 1 is greater than x implies that x is less than 1. This is the first one. So x is less than 1. X is less than 1 means in between 0 to 1 only. No? In place of mod 1 minus x, you have to write 1 minus x. Write it clearly. Integral 0 to 1. You remove this modulus and write simply 1 minus x into dx. Now come to the second case. Mod 1 minus x is equal to minus of 1 minus x if 1 minus x is less than 0. 1 is less than x, that implies that x is greater than 1. X is greater than 1 means what? 1 to 2. Integral 1 to 2 mod 1 minus x, you can write as minus of 1 minus x. So minus integral 1 to 2 1 minus x dx. I hope you understand. Here I am keeping minus, dear students. Minus of 1 minus x. That's what I wrote. Now automatically normal integration you have to do here. Modulus was removed by the conditions. So here integral 0 to 1 1 into dx. 1 into dx is dx minus integral 0 to 1 x into dx minus integral 1 to 2 1 into dx minus into minus is plus integral 1 to 2 x dx. So normal integration, integral dx is x, applying the limit 0 to 1 minus integral x dx x square by 2, applying the limits 0 to 1 minus integral dx x, applying the limits 1 to 2 plus integral dx x square by 2 x dx 1 to 2. So first upper limit in place of x 1 minus 0 minus x is equal to 1, substitute 1 by 2 minus 0 minus 2 minus 1 plus 2 square by 2. So 2 square by 2 minus 1 by 2, 1 square by 2. So 1 minus 0 is 1 minus 1 by 2 minus 2 minus 1 is 1 plus 2 square 4, 4 by 2, 2 minus 1 by 2. So here plus 1 minus 1 get cancelled. 2 minus 1 by 2 minus 1 by 2 minus 1, which is equal to plus 1. Therefore, integral 0 to 2 mod 1 minus x dx is equal to 1. I hope you understand it, students. Similarly, we will do that question number 9. So, integral 0 to 4 mod 2 minus x. In between 0 to 4, 2 is there. So, the given integral can be split as 0 to 4 can be divided into two integrals, 0 to 2, 2 to 4. So, integral 0 to 2 mod 2 minus x into dx plus integral 2 to 4 mod 2 minus x into dx, which is equal to, in between 0 to 2, what is the value of mod 2 minus x? In between 2 to 4, what is modulus of 2 minus x? That I will explain here. So, mod 2 minus x is equal to plus 2 minus x if 2 minus x is greater than 0. So, 2 is greater than x, that implies that x is less than 2. X is less than 2 means in between 0 and 2 only. So integral 0 to 2, in place of mod 2 minus x, simply 2 minus x you write it and integrate. Now come to the second case. This is the first case. Now come to 2 to 4 case. Mod 2 minus x is equal to minus of 2 minus x if 2 minus x is less than 0. 2 is less than x, that implies that x is greater than 2. X is greater than 2 means in between 2 to 4 it will be there. So minus of 2 minus x, in place of mod 2 minus x, minus of 2 minus x, you write it minus of integral 2 to 4 2 minus x into dx. So normal integration each and every term, 2 into dx. So 2 into integral 0 to 2 dx minus integral 0 to 2 x dx minus 2 into dx, 2 constant, integral 2 to 4 dx, minus into minus is plus, integral 2 to 4 x dx. So which is equal to 2 into integral dx is x 0 to 2 minus integral x dx, x square by 2, applying the limits 0 to 2, minus 2 into integral dx is x, applying the limits 2 to 4, plus integral x dx, x square by 2, applying the limits 2 to 4, which is equal to 2 into 2 minus 0 minus 2 square by 2 minus 0 minus 2 into 4 minus 2, upper limit minus lower limit, plus 4 square divided by 2 minus 2 square divided by 2. Now 2 to the 4 minus 2 square by 2 is 2. 4 minus 2 is 2. 2 into 2, 4 minus 4. 4 square by 2. 4 square by 2 means 16 by 2 is 8. Minus 2 square by 2 is 2. So here plus 4 minus 4. Minus 2 minus 2 minus 4 plus 8. 8 minus 4, which is equal to 4. Therefore, integral 0 to 4 mod 2 minus x dx is equal to 4. So this type of question we may expect in the public exam, dear students, and it will be very important question in the competitive exam itself. We'll do that different questions of 7B exercise. 2 marks questions. Number of 2 marks questions are there. Practice. Only thing is practice. As well, some formulas also we need to learn. The next question number 10. Integral 0 to 4 x square by 1 plus x into dx. So how to do this type of problems is, numerator in terms of denominator you have to make it. See here how to make is, 1 plus x is there, we need to get 1 plus x in the numerator. So integral 0 to 4 x square by 1 plus x. So for this we are subtracting 1 and adding 1 and make it as first term, 1 as second term. After that split into 2 integrals. Integral 0 to 4 x square minus 1 by 1 plus x into dx plus integral 0 to 4 1 by 1 plus x into dx. I hope you understand, dear students. X square minus 1, a square minus b square, a plus b into a minus b. Integral 0 to 4 x square minus 1 can be written as x minus 1 into x plus 1 divided by 1 plus x into dx plus integral 0 to 4 1 by 1 plus x into dx. Here x plus 1, 1 plus x will be cancelled. After that, normal integration, integral 0 to 4 x minus 1 into dx plus integral 1 by x log mod x So log mod 1 plus x, applying the limits 0 to 4. Each and every term you have to integrate. Integral 0 to 4 x dx minus integral 1 into dx. Integral 0 to 4 dx plus, in place of x upper limit, log 1 plus 4 minus log 1 plus 0. So integral x dx, x square by 2, applying the limit 0 to 4, minus integral dx, x, applying the limit 0 to 4, plus log 1 plus 4 is log 5, minus log 1, log a minus log b, log a by b. In the next step we will write it. Here x square by 2, x upper limit x is equal to 4, substitute. 4 square by 2 minus 0 minus 4 minus 0 plus log a minus log b, log a by b. So log 5 by 1. 4 square by 2 means 16 minus 4 plus log 5, that is also equal to 16 by 2. 8 minus 4, 4. 4 plus log 5. Are you able to see here? Yeah. So 4 square by 2 is 16 by 2 is 8. 8 minus 4 plus log 5. 4 plus log 5. We'll move on to the next one. Similarly, here numerator in terms of denominator we converted. Even here also easy to convert. Denominator is x square plus 2, numerator is x. So adding and subtracting plus 2 and minus 2, numerator in terms of denominator is there. After that you can split into 2 terms and then integrate. So here integral minus 1 to 2, denominator is x square plus 2, no? So x square plus 2 minus 2, adding and subtracting by x square plus 2 into dx, which is equal to integral minus 1 to 2 x square plus 2 by x square plus 2 into dx minus 2 divided by integral x square plus 2 into dx, minus 1 to 2. So these two will be cancelled. Integral dx is x, applying the limits minus 1 to 2 minus 2 into integral minus 1 to 2 1 by x square plus 2 can be written as root 2 whole square into dx. So upper limit minus lower limit, 2 minus of minus 1. This term is over. Minus 2 into. It is in the form of integral 1 by x square plus a square. Here I will write the formula. Here integral 1 by x square plus a square dx is equal to 1 by a into tan inverse of x by a. So a is equal to root 2 here, 1 by root 2, tan inverse of x by a, x by root 2, applying the limits minus 1 to 2. So 2 minus of minus 1, 2 plus 1 is 3, minus root 2 times will be cancelled. Root 2 into x is equal to 2, substitute tan inverse of 2 by root 2 minus tan inverse of minus 1 by root 2, which is equal to 3 minus root 2 into tan inverse of root 2, 2 dividing by root 2 times. Root 2 times it will be divided. Minus tan inverse of minus 6 minus tan inverse plus tan inverse of 1 by root 2. So we can stop it here. Not compulsory to do that. The rest of the answer. You can leave it like this. We'll move on to the next question. Here. Integral 0 to 1 x square by x square plus 1 into dx. Integral 0 to 1 x square plus 1 is there in the denominator. So we are adding and subtracting plus 1 and minus 1 by x square plus 1 into dx. After that we can split into 2 terms. Integral 0 to 1 x square plus 1 by x square plus 1 into dx minus integral 0 to 1 1 by x square plus 1 into dx. These two will be cancelled. Integral dx is x. In the next step I will write it. Integral 0 to 1 into dx minus integral 0 to 1 by x square plus 1 into dx. Integral dx is x, applying the limit 0 to 1 minus integral 1 by x square plus 1 tan inverse x, applying the limits 0 to 1. So 1 minus 0 minus tan inverse of 1 minus tan inverse of 0. So 1 minus 0 is 1 minus tan inverse of 1 is pi by 4 minus tan inverse of 0 is 0, which is equal to 1 minus pi by 4. I hope you understand this, friends. We'll move on to the two more examples. The next question. Integral 0 to 2 root 4 minus x square dx. Integral 0 to 2 root of 4 can be written as 2 square minus x square into dx. It is in the form of integral root over a square minus x square dx, x by 2 root of a square minus x square plus a square by 2 into sine inverse of x by a. We need to learn the formula, dear students. Directly you can apply this formula and then apply limits integrate. So, which is equal to root of a square minus x square, no, x by 2. So, x by 2 root of a square minus x square, that means 2 square, 4 minus x square. Otherwise 2 square minus 2 only you can write it. Plus a square value is what? 2 square by 2. Sine inverse of x by a value is what? 2. So formula we applied now. So applying the limit 0 to 2. So first wherever x is there, replace with 2. So 2 by 2 root of 2 square minus 2 square plus 2 square by 2 means 2 sine inverse of 2 by 2. So upper limit completed minus lower limit. X is equal to 0, substitute here. 0 into anything is 0 plus 2 square by 2 means 2 into sine inverse of 0, which is equal to this value also 0 plus 2 into sine inverse of 1. In the next step I will write it minus 0 plus 0. So 2 into sine inverse of 1 is pi by 2. 2 to get cancelled, pi. Therefore, integral 0 to 2 root over 4 minus x square dx is equal to pi. We'll move on to the next question. Integral minus pi by 2 to pi by 2 sine mod x dx. So minus pi by 2 to pi by 2 means in between minus pi by 2 to pi by 2, 0 is there. So here minus pi by 2, 0, pi by 2. In between minus pi by 2 to 0, this function value in between 0 to pi by 2. That means minus pi by 2 is less than x is less than 0. Sine mod x value is equal to minus sine x. This is the first case. In between 0 to pi by 2, 0 is less than x is less than pi by 2. Sine mod x is equal to plus sine x. So this can be integral minus pi by 2 to 0 sine mod x dx plus 0 to pi by 2 sine mod x. First we split it into two integrals. In between minus pi by 2 to 0, sine mod x value is what? Minus sine x, which is equal to minus pi by 2 to 0. Sine mod x value is minus sine x dx plus integral 0 to pi by 2 sine mod x value is plus sine x. Integral pi by 2 to 0 sin x dx. Integral sin x is minus cos x. So already minus is there. Minus cos x. Applying the limits minus pi by 2 to 0. Plus integral sin x is minus cos x. Applying the limit pi by 2 to 0. Sorry, here 0 to pi by 2. So here also 0 to pi by 2. So minus into minus is plus. Cos x minus pi by 2 to 0 minus cos x 0 to pi by 2. So first x, in place of x, upper limit cos 0 minus cos minus pi by 2 minus cos pi by 2 minus cos 0. Cos 0 value 1 minus cos pi by 2 value 0 minus cos pi by 2 0 minus cos 0 value is 1, which is equal to 1 minus 0 is 1, minus into minus is plus, 1 plus 1 is equal to 2. So therefore, integral minus pi by 2 to pi by 2 sin mod x, that is conclusion we will give it, minus pi by 2 to plus pi by 2 sin mod x dx is equal to 2. We'll move on to the last 2-3 questions. I will end the session. Video 1, VSAQ'S of the definite integration. The next question is the last questions, examples, which are all are example questions before 7b and 7a. Normal questions. Integral 1 to 2 x power 5. Integral x power n is what? X power n plus 1 by n plus 1. So integral x power 5. X power 5 plus 1 by 5 plus 1. 6. Applying the limits 1 to 2. So in place of x, upper limit 2 power 6 divided by 6 minus x is equal to 1. 1 by 6. 2 power 6. What is the value of 1 by 6? Take out common. 2 power 6. 2 power 5 is 32. 32 2s are 64 minus 1. 63 by 6. Integral sin x minus cos x. Applying the limits 0 to pi. Minus cos pi minus cos 0. Minus cos pi value minus 1 minus 1 minus 2 into minus 1 minus of minus 2 plus 2. Integral 1 by x square plus a square. So 1 by direct formula, integral 1 by x square plus a square, limits we can limit. Integral 1 by x square plus a square means 1 by a into tan inverse x by a. After writing this formula, you have to apply the limit 0 to a. 0 to a. So 1 by a. First in place of x, upper limit substitute. Tan inverse of a by a minus tan inverse of 0 by a, which is equal to 1 by a into tan inverse of 1 minus tan inverse of 0 is 0. Tan inverse of 1 is pi by 4. So that is equal to pi by 4a. So integral 0 to a 1 by x square plus a square is pi by 4a. So we will move to the last question in this session. Even 63 by 6 also we can simplify now. Just I am getting now idea. By 3 table. 3 21s, 3 2s are. 3 2s are, 3 1s are, 3 2s are. So 21 by 2. Now come to the last question. Integral 1 to 4 x into square root of x square plus 1 into dx. Either substitution or formula method we can do that. Before that, substitution only I am taking. Put x square minus 1 is equal to t or f of x. Better to take f of x. So t only can take. Differentiate with respect to x. Divide x of x square to x constant derivative 0, which is equal to t derivative with respect to x dt by dx. So cross multiply, it will becomes 2x dx is equal to dt. In that I want only x dx. So 2 we can take here. So x dx is equal to dt by 2. X dx is equal to dt by 2. So after that, whenever you are taking addition, limits will change, So first upper limit ul. When x is equal to 4, so x is equal to 4, substitute here. So x is equal to 4, substitute 4 square. 16 minus 1 is equal to t. That implies t is equal to 15. So lower limit, when x is equal to 1, so 1 minus 1, that is equal to t, therefore t is equal to 0. Therefore, the given integral 1 to 4 x into square root of x square minus 1 into dx can be written as, these x values in terms of t is going to convert. So integral 1 to 4 now. So lower limit is 0, upper limit is 15. In place of x dx dt by 2, so 1 by 2 we can take out dt. So root t, root x square minus 1 is root t. What is integral root x? Integral root x dx is equal to 2 by 3 into x power 3 by 2. So integral root t, already 1 by 2 is there. Integral root t is 2 by 3 into t power 3 by 2. Applying the limits 0 to 15. Here 2 get cancelled, 1 by 3. T power 3 by t value, substitute 15. 15 power 3 by 2 minus t whole power 0. Sorry. The t value 0 is 0. So 1 by 3. X power 3 by 2. You remember that x power 3 by 2 is x root x. We can write it. So 15 power 3 by 2 is 15 root 15. Which is equal to 3 ones are 3 5s are 5 root 15. I hope you understand, dear students. Otherwise you can leave it like this also. 15 power 3 by 2 by 3 also we can leave it. But if you want to simplify, this is the way you can do that. Thank you for watching our channel. The exercise 7B VSAQ'S I covered. This is video 1 of definite integration. Till here we may expect in TS. Not only this but also the next video, it will be helpful for the AP. Reduction formulas in definite integration related questions in the next video. I am going to do that. Thank you, dear students, for watching our channel Maths with Manindra. Jai Hind. Hi dear students, welcome to our channel Maths with Manindra. In this video, we are going to discuss about reduction formulas in definite integration and examples also. I am going to give that for 2 marks VSAQ'S. This video in 2022, it will help for only AP students. In 2022 only, dear students. After that we can use. So first, the reduction formula, integral 0 to pi by 2 sin power nx dx is also equal to integral 0 to pi by 2 cos power nx dx. So first write that formula when n is even number, when n is odd number. So integral 0 to pi by 2 sin power nx dx is equal to integral 0 to pi by 2 cos power nx dx. Observe carefully when I am writing. In the numerator, n minus 1 divided by n into n minus 3 divided by n minus 2 into, if you observe in the numerators, odd numbers we are subtracting from 1. n minus 5 divided by n minus 4 and so on till the number get 1 by 2. Whenever you are reaching to 1 by 2, immediately multiplying with pi by 2, this case will arise if n is even number. In case of odd number, just n minus 1 by n, same thing only, into n minus 3 divided by n minus 2 into n minus 5 divided by n minus 4 into and so on till the number get 2 by 3. Whenever you got 2 by 3, you have to multiply with 1. You understand that this case will arise if n is odd. I will give that examples for understanding of this reduction formula. Suppose integral 0 to pi by 2 sin power 6x dx, one even number, one odd number case I will explain, dear students. I will take one sine, another one is cos. So by observing the given question, integral 0 to pi by 2 sin power 6x dx. Here n is equal to 6 is an even number. So we have to follow this formula. 6 minus 1 divided by 6 into 6 minus 3 divided by 6 minus 2, 6 minus 5 divided by 6 minus 4. You take the meaning here. 6 minus 5 means what? 1. 6 minus 4 is what? 2. So whenever we got 1 by 2, you can stop it here and you have to multiply with pi by 2. That's our answer. And after that you can simplify, which is equal to 6 minus 1 by, that means 5 by 6 into 6 minus 3 by 6 minus 2, 3 by 4 into 1 by 2 into pi by 2. So 3 ones are, 3 twos are. So 5 into pi, 5 pi in the numerator by 2 fours are 8, 8 twos are 16, 16 twos are 32. I hope you understand, dear students. Whenever n is even number, till the number gets 1 by 2, you can stop it here, immediately multiplying with pi by 2. Next, another question I am taking here, cos with odd number I will take for this example. Example 2, integral 0 to pi by 2 cos power 7x into dx. So n is equal to 7 is an odd number. 7 minus 1 divided by 7. 7 minus 3 divided by 7 minus 2. 7 minus 4 divided by, 7 minus 5 divided by 7 minus 4. 7 minus 5 is 2, 7 minus 4 is 3. So 2 by 3 we got. Whenever we can stop there, 2 by 3, after that multiplying by 1. No need to multiply, just this is the procedure, which is equal to 7 minus 1, that means 6 by 7 into 4 by 3, 4 by 5, 2 by 3. which is equal to, so 3 ones are 3 twos are 2 fours are 8, 8 twos are 16 divided by 35. That's all. I hope you understand, dear students. This is the way the reduction formulas you can do that. The next integral 0 to pi by 2 sine power mx cos power nx dx. Here also 1 minute, dear students. Yes, easy to see. M is even, N is odd, M is odd, N is even. Different cases will come now. But by using only one and only formula which I am going to explain here, if you remember that, you are able to do any type of question based on this. See here, integral 0 to pi by 2 sine power mx into cos power nx dx is equal to, in the numerator, m minus 1, odd number subtract, m minus 3, m minus 5 and so on, based on the number of, based on the value of m, into same procedure for n also, n minus 1, n minus 3, n minus 5 and so on, by denominator m plus n, sum of these values, m plus n. Next subtract 2 to number, m plus n minus 2 into m plus n minus 4 and so on, into k. Here what represents k, that I am going to give you here. K is equal to pi by 12 if m comma n are even, that means both are even. K is equal to 1, otherwise means what? Otherwise meaning is m value even, n value odd, m value odd, n value even, or m and n values both are odd. Only in the case of k equal to pi by 2, the value of m and n values should be even number. K is equal to 1 is otherwise. These are the very key points. This is the case 2. This is case 2. This is case 1. You remember, dear students? I will take example for every case. See here, first example, both even we will consider. Integral 0 to pi by 2 sine power 6x into cos power 4x dx. Observe carefully. M is equal to 6, n is equal to 4. Both are even numbers. So both are even numbers, means keep in mind k value should be pi by 2 based on this. You have to follow numerator m minus 1, that means 6 minus 1, 6 minus 3, 6 minus 5. You cannot write 6 minus 7. Why? Because you cannot get any negative numbers and you cannot get any values of zeros. So till there you can stop it into n minus 1. That means n value is what here? 4. 4 minus 1 into 4 minus 3. You cannot proceed for the next term. Numerator completed. Come to the denominator. What is m plus n? 6 plus 4. Subtract 2 from the denominator. Even numbers. 6 plus 4 minus 2. 6 plus 4 minus 4. 6 plus 4 minus 6. 6 plus 4 minus 8. You do not write 6 plus 4 minus 10. Why? Because 0 will come. You can stop it here. We know that 6, 4 both are even numbers. In place of k directly I am going to put as pi by 2. Do you understand, students? Now simplification, which is equal to 6 minus 1, 5 into 3 into 1, 4 minus 1, 3 into 4 minus 3 is 1 by 6 plus 4, 10 into 10 minus 2, 8, 10 minus 4, 6, 10 minus 6, 4, 10 minus 8, 2, we can stop it here, into pi by 2. Now only simplification. So 3 ones are, 3 twos are. There is no possibility to divide the numerator values, which is equal to 5 into 3, 15 into pi, 15 pi, divided by, sorry, 5 ones are 5 twos is there, no? Sorry. Next, 3 into pi, 3 pi, divided by 8 twos are 16, twos are 32, 32 into 16, 32 into 16, so 512. I hope you understand. This is the example for m and n both are even number. Another question we will discuss, we will consider, one is even number, one is odd number. Here only we will consider integral 0 to pi by 2 sin power 5x into cos power 4x into dx. Odd, even. This formula we are going to follow. 5 minus 1 according to the procedure. 5 minus 3. We cannot write 5 minus 5. So you can stop it there. Come to the 4. 4 minus 1. 4 minus 3. We cannot write 4 minus 5. Leave it like this. By. Next, sum of these two. 4 plus 5. Sorry, 5 plus 4. Anything is okay. 5 plus 4 minus 2. 5 plus 4 minus 4. 5 plus 4 minus 6. Next, 5 plus 4 minus 8. After that, you cannot write. You can leave it there. M value and n value. One is even, one is odd means you have to write in place of k 1. Now simplification. 5 minus 1 is 4 into 2. 4 minus 1 is 3 into 1 by 5 plus 4 9. 9 minus 2 7. 9 minus 4 is 5. 9 minus 6 is 3. 9 minus 8 is 1. Into 1, no need to write. Here 3 get cancelled. 8 divided by 63. 9 7 is 63 into 5. 315. So 8 by 350. This is the way we can. I'll see that. Is there any possibility to? Yeah, more. One other case also here on I will explain. Now we will take that integral 0 to pi by 2 sin power 4x cos power 5x into dx. So based on this same situation, 4 minus 1, 4 minus 3, we can stop it there. 5 minus 1, 5 minus 3, we cannot write 5 minus 5, by 5 plus 4, 5 plus 4 minus 2, 5 plus 4 minus 4, 5 plus 4 minus 6, 5 plus 4 minus 8 into 1. Again same values only will come. In the numerator 3 into 1, 4 into 2 by 9 into 7 into 5 into 3 into 1. So 8 by 315. Now we will consider both are odd. Integral 0 to pi by 2 sin power 5x into cos power 5x dx. 1 minute, let us see. Is there any? Yeah, easy to see that. It's not a problem. Sin power 5x, cos power 5x. Both are odd numbers. So again, we have to follow 5 minus 1, 5 minus 1, 5 minus 3. We cannot write 5 minus 5. In the next also 5 minus 1 into 5 minus 3. Come to the denominator. In the denominator 5 plus 5 m plus n. Next 5 plus 5 minus 2 m plus n minus 2. Next 5 plus 5 minus 4. 5 plus 5 minus 6. 5 plus 5 minus 8. You can stop it here. Into 1. Not compulsory to write it. 5 minus 1 is 4. Into 2. 4 into 2 by 10. 8. Next 10 minus 4, 6. 4. 2. So 4 2 4 2 cancel. Even here also 4 2 4 2 cancel. 1 by 60. These are the reduction formulas when n is even number, when n is odd number. In the previous question also we discussed whether it is sin power nx or cos power nx. The formula is same when n is even number, when n is an odd number. That examples also I covered, dear students. Thank you for watching our channel. Only these type of questions will help you in 2 marks. Substitution method is there, that it will come for 4 marks. I am going to end the session. Thank you, bye. Hi, hello dear students. Welcome to our channel Maths with Panindra. In this video, we are going to discuss about very short answers questions from differential equations. Exclusive video. It will be helpful in Telangana and Andhra Pradesh students of intermediate second year MATHS2B. It will help you. First half an hour it will help for that TS students, especially in 2022. After that some questions from linear differential equation. It will help for the AP students in 2022. So let us have a discussion. And before going to discuss the questions, what type of questions they may chances to ask in differential equations. The first preference, foremost important thing, order and degree of the given differential equation. Second one, formation of differential equation. Third one, they will give one family of circles or family of any conic. Ask them to find the differential equation regarding that. And come to the variable separable method. Find the general solution. Find the solution. Come to linear differential equation. They will ask find integrating factor for the given differential equation, linear differential equation in x, linear differential equation in y. These type of questions I will discuss in this video, dear students. Let us have a discussion. The first question. Find the order or degree of the differential equation dy by dx equal to x power 1 by 2 by y power 1 by 2 into 1 plus x power 1 by 2. If we observe that this differential equation, it contains only dy by dx equal to some polynomial in x. So, dy by dx equal to x power 1 by 2 by y power 1 by 2, 1 plus x power 1 by 2. So, it is a differential equation. In the differential equation, what is the differential coefficient? Dy by dx is the differential coefficient. Highest order derivative is also dy by dx, whose power is called degree. This is called degree. Here this value is called order. So, order for the differential equation is 1 and the degree for this differential equation is 1. If we come to second question, find order and degree of this differential equation. D square y by dx square equal to 1 plus dy by dx whole square whole power 5 by 3. If you do that, here whole power 5 by 3, whenever whole power 5 by 3, whole power 1 by 5, whole power 6 by 5, like this differential equations is given. First you have to remove the radicals from the given differential equation by powering the values, respective values, and then find order and degree. So here I want to remove the radical form. So how to do that? Cubing on both sides, you have to do that. Cubing on both sides. After that, it will become d square y by dx square whole power 3 is equal to, whenever whole cube it we are doing now, 3 get cancelled, 1 plus dy by dx whole square whole power 5. Now observe that among these values, which one is having highest order derivative? Among dy by dx whole square and d square y by dx square, highest order derivative is this only. D square y by dx square is the highest order. Dy by dx means first order. D square y by dx square is second order. So this is the highest order derivative. Highest order derivative power is called degree. This is called degree. So this is called order. So order of the differential equation is 2 and degree of the differential equation is 3. I hope you understand it, students. We'll move to the question number 3. This question may chances to ask to confuse the students. Why? Because the question is special here. D square y by dx square plus 2 into dy by dx plus y is equal to log of dy by dx. To calculate degree and order, for order, highest order derivative occurring in the differential equation, we can take it. For the degree, the differential equation should be a polynomial in differential coefficient. By observing here, log of dy by dx means it is not the polynomial in differential coefficients. If you are not able to express the differential equation in terms of polynomial of differential coefficients, so for that type of equations we cannot find the degree, and for the order we can find out highest order derivative is the order. So here order for this differential equation is order is equal to 2. Why? Because d square y by dx square dy by dx, among these two this is the highest order derivative. So d square y by dx square is equal to, here order is 2. For the degree we cannot write it. Why? Because this is the differential equation, okay, but log of something, if you remove log, it will become exponential of this value. Whenever it is in terms of exponential, we are not able to express in the polynomial of differential coefficients. That is the reason degree cannot be defined. Degree cannot be defined. Since we cannot express as polynomial in differential coefficients. Polynomial in differential coefficients. I hope you understand, dear students. Next, we will move to the question number 5. In question number 4, dy by dx whole power 1 by 2 plus d square y by dx square whole power 1 by 3 whole power 1 by 4 equal to 0. So first what we have to do, this radical we need to remove by power rising to 4. So if you power rise to 4, this value goes to be 0. Whole power 4, if you apply, this value goes to be, this is equal to 0. Power rise to 4, this will becomes dy by dx whole power 1 by 2 plus d square y by dx square whole power 1 by 3 is equal to 0. So what happens 1 by 4? If you power rise to 4, this is going to eliminate. So after that, this dy by dx whole power 1 by 2 I am taking here, d square y by dx square whole power 1 by 3, which is equal to minus dy by dx whole power 1 by 2. This side whole power 1 by 3 is there, this side whole power 1 by 2 is there. Generally, here whole power 5 by 3 is there, so cubing on both sides we discussed, we did that. But here, doubt will arise, whether I have to continue with cubing on both sides or squaring on both sides. Whenever whole power 1 by 3, whole power 1 by 2, both cases are available in the same question, the LCM of 3 and 2, you can power rise. So power rise to 6. So if you do that power rise to 6, this equation will becomes d square y by dx square whole power 1 by 3 whole power 6, which is equal to whole power 6 means minus will become plus. So dy by dx whole power 1 by 2 whole power 6. So 3 ones are 3 twos are 2 ones are 2 threes are. Therefore d square y by dx square whole power 2 is equal to dy by dx whole power 3. Now among these d square y by dx square and dy by dx, what is highest order derivative? D square y by dx square is the highest order derivative. So order is 2. So this is the order, this is the degree. So degree is 2. Now come to this question. This is the differential equation, d cube y by dx cube whole square minus 3 into dy by dx whole square minus e power x equal to 4. It is a clearly differential equation in a polynomial in differential coefficients. So what is the highest order derivative? D cube y by dx cube is the highest order coefficient. So this is the degree, this is order. So order of the differential equation, order is equal to 3, degree is equal to 2. Yeah, we'll move on to the other questions. Find the order and degree of the following differential equations. So till here I am going to finish the concept of order and degree. After that, we will enter into the form a differential equation concepts, finding order, including that. So here, x power 1 by 2, d square y by dx square whole power 1 by 3 plus x into dy by dx plus y equal to 0. So whole power 1 by 3 is there. I want to make the radical form into the original form. That means general form. I want to remove this radical form. So x power 1 by 2, d square y by dx square whole power 1 by 3 is equal to minus of x into dy by dx plus y. I want to remove 3 here, so cubing on both sides. So if you do that cubing on both sides, x power 3 by 2 will come here, d square y by dx square whole power 1 by 3 into 3 get cancelled, 1 will come, minus cubing times 3 times, odd number of times minus only will come, x into dy by dx plus y whole cube. In this, highest order derivative is d square y by dx square only. No? So highest order derivative power is called degree. It is called order. So therefore order is equal to 2, degree is equal to 3. Now come to the next question number 7. D square y by dx square plus dy by dx whole cube whole power 6 by 5 equal to 6y. Here also I want to remove the power. See, whole power 6 by 5, whole power 1 by 3, whole power 1 by 2, whole power 1 by 4 is there. That time we can power rise to 5, 4 and all. But whenever 6 by 5 is there, we can remove completely the 6 by 5. So by power rise to 5 by 6 on both sides. So like this way, d square y by dx square whole plus dy by dx whole cube whole power 6 by 5 power rise to 5 by 6 is equal to 6y power 5 by 6. So therefore this differential equation will becomes d square y by dx square plus dy by dx whole cube is equal to 6y whole power 5 by 6. So highest order derivative is here only. So highest order derivative is order is 2, degree is 1. So this is the degree, this is order. I hope you understand. We'll move to the question number 8. Find the order of the differential equation to the corresponding equation. Here the given equation is y equal to a into e power x plus b into e power 3x plus c into e power 5x. Very important note. They are asking only order of the differential equation. In the given equation, how many arbitrary constants are there? First you have to find, dear students. So A, B and C. These are the 3 arbitrary constants. The order of the differential equation is the number of arbitrary constants occurring in the given equation. The order of given differential, order of differential equation is equal to the number of constants or simply arbitrary constants. Arbitrary constants. In the given equation. So how many arbitrary constants are there? A, B and C. So total 3. So therefore the order of the given equation is differential equation. Generally how to do this differential equation from the given equation is 3 constants are there means the given equation you have to differentiate 3 times and get y1, y2, y3 respectively. From these 3 equations, you have to eliminate A, B, C by solving the equation. So get the differential equation. But they are not asking differential equation. What is the order of the differential equation to the corresponding given equation? So that is the reason. This is a VSAQ only, no? So we need to only write this comment. Very important point. This is the order of the differential equation is equal to the number of arbitrary constants in the given equation. So these 3. We'll move on to the next question. The next question, question number 9. Sometimes this question is asking for 4 marks, sometimes they are asking for 2 marks. Form the differential equation corresponding to y equal to a cos 3x plus b sin 3x, where a comma b are 2 parameters. See here, dear students, a and b are 2 constants, it's 2 times you have to differentiate. So given equation y is equal to, I am not writing complete steps. Given equation you have to write it, y is equal to a cos 3x plus b sin 3x, keep it as equation number 1. So 2 constants are there means you have to differentiate twice. So first time we are differentiating dw or dx, differentiate with respect to x on both sides. So y derivative is y1 or dy by dx. A into dy by dx of cos 3x, dy by dx of cos ax is minus a into sin ax. So minus 3 into sin 3x plus b into d by dx of sin 3x. d by dx of sin ax is a cos 3ax. So 3 cos 3x. Again differentiate with respect to x. Why we are doing again differentiate with respect to x? One more constant is there. So that is the reason. y1 will becomes y2 minus 3a constant we can take out. And d by dx of sin ax. So sin 3x is 3 cos 3x. 3b constant, dy by dx of cos 3x minus 3 sin 3x. So minus 3 into 3 minus 9, a into cos 3x. Here minus 9 also have taken common, so b into sin 3x. So a cos 3x plus b sin 3x from equation 1, that value is y. Since from equation 1, so minus 9y. So y2 means d square y by dx square also we can write it. Minus 9y we can take this side. Therefore d square y by dx square plus 9y is equal to 0, which is the required differential equation to the corresponding given equation. Now we'll move on to the question number 10. Form the differential equation to the equation y equal to cx minus 2c square, where c is a parameter. So c equal to y equal to cx minus 2c square, given equation, we have to write it. How many constants are there? Only one constant is there. So differentiate with respect to x one time. So y derivative is y1 is equal to c into x derivative is 1 minus constant derivative 0. So that implies that y1 is equal to c. So wherever c is there in the given equation, replace with y1 and write it the equation. Therefore, y1 is equal to c. Substitute in equation 1, we get y equal to x into y1 minus 2 into y1 square. So all these values we can take here. Therefore, 2 into dy by dx whole square minus x into dy by dx plus y equal to 0, which is a required differential equation. They are asking here, form the differential equation, means we got it. Next, question number 11. Obtain the differential equation which corresponds to the rectangular hyperbolas. This is very important. Which have the coordinate axis as asymptotes. The family of rectangular hyperbolas whose axes are asymptotes is xy is equal to c square, where c is a parameter. This is the very important. Without knowing this information, we cannot do the further steps. You remember that, dear students, the equation, the family of equations of rectangular hyperbolas which have the coordinate axis as asymptotes is xy is equal to c square. You have to mention. After that, how many constants are there? C square. C is one constant. So differentiate with respect to x. UV formula. X into y derivative is dy by dx plus y into x derivative is 1 and constant derivative 0. Therefore, x into dy by dx plus y equal to 0, which is the required differential equation to the corresponding equation of family of rectangular hyperbolas whose coordinate axis as asymptotes for this equation. I hope you understand which is the required. Very important thing is you need to mention here the family of rectangular hyperbolas. Rectangular hyperbolas whose axes are as asymptotes is. So like this you have to write the matter and write the equation xy equal to c square. For that 1 mark. For differentiating one time and getting the differential equation, 1 mark. This is the way you can do, dear students. This type of question may chances to ask. Why? Because the student don't know about xy equal to c square. Of course, they studied the rectangular hyperbolas. Like this equation has x square minus y square equal to a square. But not like this equation. So this is the equation regarding the question. We may expect this type of question in 2 marks especially. And even this question will help in the competitive exam system itself. Find the order of the differential equation, the family of all circles with their centers at origin. Even this is also important one. We will expect for 2 marks. Find the order of differential equation, the family of all circles. Here you have to mention that the equation of family of circles, whose center at origin is x square plus y square is equal to r square or a square, where r is the radius. This is the only constant here. So x square plus y square is equal to r square. This is the equation. How many constants are there? One constant, radius. So differentiate with respect to x one time. X square derivative 2x plus y square derivative 2y, and y derivative is dy by dx, which is equal to constant derivative is 0. 2 take common and we can take this side. X plus y into dy by dx is equal to 0. In this differential coefficient is dy by dx itself. Therefore, the order of this differential equation, they are asking order. So, therefore, order of this differential equation is 1. First order derivative. I hope you understand now. We will move on to the questions related to variable separable method, 2 marks questions. Now, the next question. These questions from variable separable. Solve dy by dx equal to 1 plus y square by 1 plus x square. So we need to separate that y variables one side, x variables another side. So here, first given differential equation, you write it. Dy by dx is equal to 1 plus y square by 1 plus x square. That implies that dy by that 1 plus y square, I am taking here the denominator. So dx by 1 plus x square. So take after completing of separating the variables x and y, taking integration on both sides. Integral dy by 1 plus y square is equal to integral dx by 1 plus x square. Integral 1 by 1 plus x square, tan inverse x. Integral 1 by 1 plus y square, tan inverse of y, equal to tan inverse of x. Either of the sides, any one of the side you can keep as a constant c plus c. So tan inverse y we can take this side. Tan inverse x plus, tan inverse y I am taking here, minus tan inverse y is equal to c. That tan inverse y I am taking here. Find the general solution of x plus y into dy by dx equal to 0. Here also, first given differential equation is GDE. X plus y into dy by dx is equal to 0. Y into dy by dx is equal to minus x. So dx we can take here. Y dy is equal to minus x dx. So taking integration on both sides, integral y dy equal to minus integral x dx. Integral y dy, y square by 2 is equal to minus integral x dx is x square by 2. So plus constant c we have to write it now. If you want c by 2 also we can write according to your convenience. Not compulsory to write only c. Even c by 2 also we can write it. But if you want to according to Telugu Academy, you write it only c. After that cancel on both sides 2 and here keep it as 2c. Now y square, take LCM 2. Minus x square plus 2c by 2. 2 get cancelled. Minus x square you can take here. Therefore, x square plus y square equal to 2c. This is called general solution of given differential equation. Now come to here. Find compulsory from this guarantee question in the VSAQ'S from variable separable if they will ask the question. Find general solution of dy by dx equal to e power x plus y. So given differential equation GDE, dy by dx is equal to e power x plus y. It is in the form of a power m plus n, a power m into a power n, e power x into e power y. Separate it. So dy by e power y is equal to e power x into dx. 1 by e power y can be written as e power minus y into dy is equal to e power x into dx. As soon as separating the variables, taking integration on both sides, integral e power minus y dy is equal to integral e power x into dx. Integral e power minus y by minus 1. So we can write as e power minus y by minus 1 means that minus we can write like this. Equal to integral e power x is e power x. Here only I am writing plus c. That will be minus e power minus y we can take here. E power x plus e power minus y is equal to c, which is the required solution, general solution of given differential equation. Now come to question number 16. Find the general solution of dy by dx equal to 2y by x. This question is already there in the model paper itself, I think. So you can practice sincerely the question. Given differential equation GDE, dy by dx is equal to 2y by x. So dx we can take here, y we can take here. Dy by y is equal to 2 times of dx by x. Taking integration on both sides, integral 1 by y into dy is equal to integral 2 into integral 1 by x into dx. Integral 1 by y, log mod y, is equal to 2 into integral 1 by x dx, log mod x. So both sides we are getting log, no constant also I am taking log c. So log y is equal to 2 times of log x can be written as log mod x square plus log c. So log y is equal to log a plus log b, log x square into c. So comparing on both sides logarithms, therefore y is equal to x squared c, which is the required solution for the given differential equation. We'll move on to 2 more questions from variable separable. After that, integrating factor. The next question. Solve dy by dx equal to e power y minus x. So first, given differential equation GDE, dy by dx is equal to e power y minus x. This can be written as e power y into e power minus x. A power m plus n, a power m into a power n is equal to n minus x now. So separate the variables. Dy by e power y is equal to dx into e power minus x. E power y we can take up numerator as so e power minus y into dy equal to e power minus x into dx. After separating the variables, taking integration on both sides. So e power minus y by minus 1 equal to e power minus x by minus 1 plus c. So this value we can take this side, e power minus x minus e power minus y equal to c, which is the required solution. Now come to question number 18. So first given differential equation is GDE tan y into dx is equal to, I am taking this side, minus tan x into dy. So here x term is there, dx, no? So tan x we can take here, dx by tan x is equal to minus dy by tan y. So the reciprocal of tan is cot. So cot x into dx is equal to minus cot y into dy. So taking integration on both sides, integral cot x dx is equal to minus integral cot y into dy. Integral cot x log mod sin x is equal to minus integral cot y log mod sin y. Both sides log we are getting now, so log c. So minus log sin y we can take here. So log mod sin x plus log mod sin y is equal to log c. Log a plus log b, log ab, log sin x into sin y is equal to log c. So comparing the log functions, the solution is sin x into sin y equal to c. That's all. We'll move on to the next one. Find the integrating factor of the given differential equation x dy by dx. So first what we have to do in the solution, here x into dy by dx is there, no? So we need to keep this equation in this form, dy by dx plus py equal to q. In this form you have to write it. So dividing by x, first the given equation is x dy by dx minus y is equal to 2x square into secant square of 2x. So dividing by x, dy by dx plus minus 1 by x into y is equal to 2x into secant square of 2x. X get cancelled directly out. This equation you have to compare here. So p is required. P is equal to minus 1 by x. And q also this value. But integrating factor for this differential equation dy by dx plus py, for this integrating factor is e power integral p dx. So e power integral p value integral minus 1 by x dx. So which is equal to e power minus integral 1 by x is log mod x. So e power, that minus also we remove, log x power minus 1. So x power minus 1, 1 by x. So therefore the integrating factor is 1 by x. So come to question number 20. Find integrating factor of y dx by dy minus x equal to y cube. So this equation you have to convert into the form of dx by dy plus px is equal to q. For this differential equation, the integrating factor is e power integral p dy. You keep in mind, dear students. So here, given differential equation is y into dy by dx by dy minus x is equal to 2y cube dividing by y dx by dy plus minus 1 by y into dx 2y square. So compared with this equation, so p is equal to here minus 1 by y, integrating factor e power integral p dy, e power minus 1 by y dy, e power minus integral 1 by y is log mod y. So if you remove minus here, e power log mod y power minus 1, so y power minus 1, that is 1 by y. Therefore the integrating factor is 1 by y for the given differential equation. I hope you understand. We'll move on to the more 3 questions to finish this session. The next question. Here the question is little different. These questions especially for AP, there's last 3 and from 17, 18, 19. These questions from AP. Remaining TS also you can prepare. Only this year 2022. Transform the equation x log x dy by dx plus y equal to 2 log x. Transform this equation into linear form. Linear differential equation means either x dy by dx, dy by dx plus py equal to q, or dx by dy plus px equal to q, any of the form. But here dy by dx term is there, means we need to keep in this form. So given equation is x log x into dy by dx plus y equal to 2 log x. So dividing throughout equation by x log x, it will becomes dy by dx plus y by x log x is equal to 2 log x by x log x. So log x get cancelled. This equation can be written as dy by dx plus 1 by x log x into y is equal to 2 by x, which is in this form, linear differential equation, which is the linear differential equation LDE. Now come to integrating factor of this differential equation. First, you have to keep this equation either in this model or dx by dy plus px equal to q. See here, given differential equation is 2x minus 10y cube into dy by dx plus y means equal to minus y. But this value, if you take this side, we cannot split into terms. So what I am doing is cross multiply. 2x minus 10y cube is equal to minus y into dx by dy I am writing. So y we can take here. 2x by y including minus if we take minus y plus 10y cube divided by y is equal to dx by dy. So here one of the y cancels, so 10y square. This minus 2x by minus y we can take here. So this equation will becomes dx by dy minus 2x by y we can take it plus 2 by y into x is equal to 10y square. It is in the form of dx by dy plus px is equal to q, where p is equal to, here p is equal to 2 by y. So integrating factor they are asking. Therefore integrating factor for this type of question, integrating factor is e power integral p dy. So integrating factor e power integral p dy is equal to e power integral p value 2 by y means 1 by y into dy is equal to e power 2 into log mod y, that is equal to e power log mod y square. So e power log y square means y square. E power log f of x is f of x. Therefore integrating factor is y square. Now we will move to the question number 23 and last question in this session. Find integrating factor of cos x into dy by dx plus y into sin x equal to tan x. The given differential equation is cos x into dy by dx plus y sin x is equal to tan x. So dividing by cos x, dy by dx plus y into sin x by cos x is equal to tan x by cos x. But they are asking only integrating factor. So this equation you have to compare with dy by dx plus py equal to q. Here p is equal to sin x by cos x. That means tan x. So whenever the differential equation is in the form of dy by dx plus py equal to q, the integrating factor is e power integral p dx. So e power integral tan x. Integral tan x is log mod secant x. E power log mod secant x. And one more formula here also I wrote directly. E power, in the previous classes I said e power log f of x is f of x. Keep in mind, dear students. So e power log secant x is secant x. Therefore the integrating factor for the given differential equation is secant x. I hope all you enjoyed. In mathematics 2B, either TS students or AP students, all the VSAQ'S topics I covered in quick revision. I kept one playlist, especially VSAQ'S quick revision. Keep in mind and follow this. Especially 2B, most of the students they feel difficult. It is not difficult, it is a different. That's all. That is the reason I made VSAQ'S of differential equations. It will help for AP student and TS students. Wish you all the best for your exams. Thank you all. Signing off, Maths with Pandit. Like and share to your friends.